morning, everyone. For those that have seen the directions already, we have a polling that we're doing right now to make this more engaging for our audience. So the question that's out there right now is, what do you think of when you hear the word ADA? And if you're going to submit a response, you can use the link that's in the chat or text 22333 and then text Michael Nauman to that number. Again, if you're going to use more than one word, please use underscore so it'll keep it all together. So good morning and welcome. My name is John Cariano. I am the support engineer here at DelDOT. I've been responsible for facilitating the update of the 2021 Pedestrian Accessibility Standards, otherwise known as the PASS Manual. So welcome to the training. We'd like to roll this out and present it to all of you. So about a year ago, we decided to look at the PASS Manual and see if there's ways that we can make it more user-friendly, more clear, and make sure that we're adhering to the minimum federal requirements in our document. So the updated manual is intended to be comprehensive and maintain it as things change. We also want to make sure we're clear on what is the standard and provide design guidance to those people that are designing, also memorialize the acceptance and RPE processes along the way. So we enlisted the services of GPI, a team of Michael Nauman and Rob McCleary, to assist us with this effort. We also developed a PASS committee that we engaged regularly along the way to review the document and provide insight on the standards, as well as developing some other documents that are closely associated with the PASS manual. So I'd like to thank those committee members that have been involved, as well as others throughout the department and our consultant partners that had reviewed the documents that we put out there. It was really a collaborative effort, and it's a testament to all of your input along the way. So we recently posted the PASS manual on the DelDOT publications page, so you can find it there under manuals. There's also an RPE form that was updated, and it's underneath that 2021 version of the document. So the training today is scheduled to run to about noon. We have a planned break around 10 o'clock. The training is going to be recorded and the slides will be available at a later time. Also, we have Q&A. The Q&A feature at the bottom of the Zoom screen should be able to answer your questions. You submit your questions there and we'll work through them to answer them. If we have some break or time at the end, we can ask Mike directly those questions that come in that we can't answer. And also we have closed captioning available for those that are interested in that. And lastly, an evaluation form will be emailed to all the participants in the training today. If you have a desire for PDH credits, you need to complete this evaluation form by October 29th. And please indicate what name or phone number you're using to attend today's training on that form, because it's hard for us to verify attendance otherwise. So at this time, I'd like to turn it over to Mike Nauman, who's going to be discussing the responses to the first question, as well as taking us through today's training. Thank you.
Okay, thank you, John. So real quick, wanted to go over the poll question. Wanted to kind of warm everybody up, but also we were kind of interested to see what the group's thoughts were on when we said ADA and what that means to them. A lot of interesting responses and very positive overall, which was great. Challenging looks like to be our #1 answer, and it is challenging. That's why we're here. That's why we had these discussions in the past. Overall, though, I think the answers show us that we all want to do the right thing. We want to create an accessible network, and we want to do that for everyone around us. So overall, very positive responses. So thank you for participating in that. So welcome everybody. My name is Michael Nauman. Appreciate everyone being here today. 4 hours is a long time, and I appreciate your commitment and time to this presentation. I know I speak for the whole update committee when I say thank you, and we're going to try to make this worth your while. Please, if you have questions, submit them in the questions chat box. We'll try to answer them Again, try to make this as most beneficial to you. Ask your questions. That's why we're here today. One thing I want to stress is that this training today is not meant as a substitute to reading the manual or using the manual when an issue arises. The training today is really to focus on the big standards, the guidance changes, and some of the policy changes that the department has undertaken. Try to give you a heads up of what's coming. Also, as John mentioned, the training will be recorded. It will be posted to the Design Resource Center once we're done. And finally, one of the nice things about the online format is that you can open up the manual, open up the documents we're talking about today as we're talking about them. So please do that, follow along, try to use the manual as we're talking about it, and ask questions if you have questions, and we can answer them in the chat box. So up front, wanted to talk about the learning objectives today. So one, we want to understand the department's ADA obligations. ADA has kind of become a broad term that we've been starting to use. And that's kind of the intention of that first question as well. But we wanted to talk about today what specifically is the department's obligation in achieving the ADA and applying the ADA. And it's important to understand our requirements as a state and also the requirements as well as how our federal partners are applying it as well. Discuss recent department standard guidance and policy updates. Again, that's the big takeaway we want to leave you with today is understanding what the department has changed with this update. Again, as John mentioned, we kind of took a look through all of our standards and practices with this update. We wanted to give everybody kind of a heads up of what those changes are. Also, we want to talk about how to understand the updated past manual. So again, we rewrote it to be more clear and concise. By doing that, we're going to try to give more clear guidance to our staff. What we want to do with this is we want to show you how to use each individual section of the past manual and also combine them as a whole to use it as an effective tool. We want to discuss the application of several of the most common elements in the public right-of-way. So one, with this, we want to boost understanding across the department of some of the subjective matters, as well as some of the matters that are not subjective that are a standard. And finally, we want to discuss the department's revised ADA inspection and acceptance process. So one of the things we wanted to do with this updated manual is to kind of memorialize several processes that the department has created. And one of those in particular was the ADA inspection and acceptance process. So about the presenters today, my name is Mike Nauman. I drew the short straw. I'll be doing a lot of the presentation. So I apologize for you having to look at my ugly mug today. Worked for DelDOT for several years as a project engineer, a project manager, and also design resource engineer. During that time, I got to see unique accessibility issues applied across the department. Additionally, we have Rob McCleary here today. Rob needs no introduction, but I'll do one anyway. Rob worked for the department for 26 years. Including 6 years as the chief engineer. During his time as chief engineer, he oversaw the implementation of the 2015 manual and 2018 manual. And Rob has quite a bit of experience of serving as an arbiter for the department on ADA issues over time. So he has a unique understanding and on the application of the ADA. So we can't start this conversation without going back to the federal requirements, the federal law. In kind of the spirit of the ADA. So this slide kind of gives you a timeline. The first major item on that timeline is the Civil Rights Act of 1964, which began the civil rights movement. It strictly prohibited the discrimination on the basis of color, race, sex, or national origin. The next one, major milestone on this timeline is the Architectural Barriers Act of 1968. This law required that buildings, facilities that are designed, constructed, or altered with federal funds meet the physical accessibility standards, meet the standards for physical accessibility. The landmark in this timeline is the 1973 Rehabilitation Act. So the Rehabilitation Act prohibits discrimination on the basis of disability in programs conducted by federal agencies. And so a quote from Section 504 from the Rehabilitation Act is that no qualified individual with a disability in the United States shall be excluded from, denied the benefit of, or subjected to discrimination under any program or activity that either receives federal financial assistance or is conducted by any executive agency or the United States Postal Service. The 1990 Americans with Disabilities Act is the final item on this timeline. And essentially what the 1990 ADA Act did is that it extended the Rehabilitation Act to all public entities, both to public entities as well as private entities. So public entities under Title II or Title III. So the federal standards. So we have our law, and the law required that the regulatory agencies adopt standards to enforce the law. So the 1990 American Disabilities Act, out of that, the DOT and DOJ adopted standards, and the standard they adopted was the 1991 ADAG, which stands for the ADA Accessibility Guidelines. The original was created in 1991 and was superseded in 2004 by the 2004 ADAG. The ADAG was adopted in 2006 by the DOT and 2010 for the DOJ. In addition to the ADAG, the DOJ adopted supplemental language in Title 28 of the Code of Federal Regulations, and in particular, 28 CFR Part 35-151. When these two are combined, it creates the 2010 ADA standards. Additionally, the DOT adopted in the Code of Federal Regulations Parts 37 and 38. Something that we're going to talk about quite a bit today is the PROWAG. The PROWAG stands for the Proposed Guidelines for Pedestrian Facilities in Public Right-of-Way. This document is not a regulatory document. It's a guidelines document that's been created by the Access Board, but has not been adopted as a standard by the DOT or the DOJ. Therefore, the ADAG is the standard, and the PROWAG is a guidelines document. And the FHWA has a statement to this effect in a memo that they released in 2006. And that's still the logic still stands today. As until the proposed guidelines are adopted as standards, FHWA considers proposed guidelines to represent best practices for accessibility issues in the public right-of-way, not covered by DOJ's or DOT's currently adopted standards. This logic of that statement became the foundation of the PASS manual. Again, one of the things that we kind of set out to do in the beginning, as John mentioned, is to find the limit of what do we have to do, what are we obligated to do under the law, and what are best practices that we should be applying where we can, but don't have to under the law if we can't. So again, as John mentioned, kind of took a look across the department's policies and practices, and came up with some updates across the entire spectrum of the department's policies and practices based on interviews with staff, seeing what's working, what's not working. And this slide kind of recaps all the items that have been changed with this update. So started by interviewing staff, saw what worked, didn't work, did research on national practices, kind of brought those back, went through some ideas with the PASS Manual Update Committee, and it arrived at what we have today. So the documents that we updated, as shown on the slide, so it's the DelDOT standard construction details. We'll talk about that quite a bit today. We'll talk about the engineering instruction PM 18001. That documents how much plan information goes into a plan set regarding pedestrian connections. Updated the ACIA, which is the ADA construction inspection application. Created a new plan review workflow, and also updated the request for practical exception form. So the intention of this slide is really to show you all the information that got encompassed into this updated manual. So the information contains standards from the DOT, DOJ, guidelines from the Access Board. It contains AASHTO manuals, MUTCD, DOT, DOJ guidance. So a lot of information went into this PASS manual, all into one location. So we tried, and the most important thing with this too is we tried to treat each document that was encompassed appropriately. So if it's a standard, we treat it as a standard. If it's a guidance that comes from AASHTO, we treat it as a guidance. So structure of the 2021 manual. It should be fairly similar to that of the existing manual, laid out pretty well. Again, conducted interviews with staff, and there was 2 items that we thought that we could really extend upon. So we created 2 new chapters to the manual. There's a new chapter 4, which is called Design Considerations. So not the standards, but tells you how to apply the standards, how to optimize the pedestrian access, the pedestrian network, that with ways that aren't considered actually standards themselves. Additionally, Chapter 5 documents the department's acceptance and inspection process. There has been some confusion on this in the past. We wanted to memorialize it in one place to have a starting point to talk from in the future. Additionally, all the other chapters have been rewritten for clarity as well. So Chapter 1 defines how the standards of the manual should be applied and describes the relationship with the federal source documents that went into the manual. One of the things that we know is that there will be disputes even after this manual is released. We wanted to give a discussion in the manual to try to give the user some information on how all the federal source documents apply and give an idea of the hierarchy to help them reach a good dispute resolution. Chapter 2 is on project type and application of standards. This is a very important concept, and we'll spend a decent amount of time on that today. Not all projects are held to the standards of new construction. However, if you're not held to the standards of new construction, it's important to understand what your obligation is under the ADA. Chapter 3 is entitled the Accessibility Standards. This is the standards for the department. If you're going to determine whether something is accessible or ADA compliant, this is the chapter you're going to go to. It's rewritten to be very clear. We use the METCD format, and we're going to talk about that more later today, but it should be very clear if you're meeting a standard or if you're not. Previously mentioned, created a new Chapter 4, and the reason we did this was to clearly break out the standards versus guidance. So there shouldn't be any question about what's a standard now versus what's a guidance. Chapter 5, again, try to add some transparency to the inspection and acceptance process. And Chapter 6, which is an existing chapter, we revamped that a little bit to add some additional information about the warrants for an RPE, and also gave some more information about the process to go about getting one approved. Where does the manual apply? So the manual applies to all department administered contracts and public right-of-way. The manual is also meant to apply to third parties performing work inside the public right-of-way. However, the manual is not a regulation, and therefore, where the manual is meant to apply to a third party, it needs to be written into the permit or agreement that the department has with the third party performing the work. The manual also does not specifically apply to buildings or structures. Buildings or structures need to follow the ADAG or appropriate Delaware building code. The manual does not apply to site work that's performed outside the public right-of-way either. Site work performed outside of the public right-of-way must follow the ADAG. The manual does not directly apply to recreational trails. Trails that are not part of the DelDOT's transportation network do not need to meet the standards in this manual. Trailheads that are part of the public network do, though, however. Parking facilities are not considered on-street parking, which would be parking garages, parking lots, must follow the ADAG standards. The standards in this manual do not apply. And finally, we have machinery spaces, which are not intended to apply to the standards in the manual. So this is an exception that comes from the PROAG and the ADAG. The department left the language very vague, similar to the federal requirements, so that way not to box ourselves in. But basically, machinery spaces are places that are not intended to be accessed by the public. Before we go any further, I think it's important that we talk about the PAR versus pedestrian circulation path. Some standards apply to just the PAR, and some apply to the entire pedestrian circulation path. So the pedestrian access route is a continuous and unobstructed path of travel provided for pedestrians with disabilities within or coinciding within the pedestrian circulation path. The pedestrian circulation path is a prepared exterior or interior surface provided for pedestrian travel in the public right-of-way. Therefore, the pedestrian access route is a portion of the pedestrian circulation path. Two other concepts that we're going to talk about today that are design concepts and not necessarily accessibility concepts are the buffer zone, buffer strip, as well as frontage zone. So the buffer strip is the area between the edge of the travel lane into the front of the pedestrian access route. This area is intended to improve operation and is not part of the pedestrian access route. The frontage zone is a desirable linear feature that runs parallel to a building or other vertical obstruction. And again, this is for a design concept. It's not an accessibility requirement. So PAR versus PCP, here's a good example. So in the middle, we see a very well-defined PAR. This is the city of Dover. You have a buffer strip on the side. You have well-defined plantings, well-defined light poles, signs. And on the far right side, you have the frontage zone. So in front of the building, no one's going to walk in that area, so it's not part of the usable route. However, that's a design concept and not an accessibility concept. So 2021 manual implementation. So the department outlined the implementation in an October 14th memo. Basically, the memo broke down implementation into 3 categories. And the categories are ADA inspection, request for practical exceptions, and design implementation. ADA inspections that will occur after November 1st are going to follow the requirements in the updated past manual. Requests for practical exceptions that are occurring after November 1st should also follow the 2021 manual. The design implementation is a little bit more complicated subject, and the department's opted to use a phase implementation for this. And we're going to talk about that a little bit more later after we talk about some of the why it needs to use a phase implementation. So chapter 2. Chapter 2 is entitled Project Type and Application of Standards. Again, very important section. It summarizes the ADA obligations associated with the project. So this chapter is created directly from the federal source documents. So again, we wanted to say, what is our legal requirements? And so what we did is we adopted the language that comes from the federal source documents. We tried to not embellish on the language or extend the language. Instead, we kind of reorganize it so it's more clear, but we kept the meaning of the federal documents. That way, we're starting from a baseline of what we are held to. Again, if we can achieve more, let's do it. If not, these are the requirements. The accessibility requirements. So on the screen are several key excerpts from Title 28, Part 35, 151 of the Code of Federal Regulations. To me, the ADAG and PROAG are more of the technical requirements, and the Title 28 contains more of the how and when to apply the standards. So the CFR language makes it very clear that new construction must comply with the 2010 standards. The CFR also requires that altered locations comply with the standards to the maximum extent feasible. So what does altered mean? And again, one thing that we're going to talk about here as well is usability. So usability is used in the CFR language, and we'll talk about that later. So what does altered mean? So altered has been defined through the courts through the years. And the landmark case in this arena is Kinney versus Jerusalem. So in this case, Kinney, who's the plaintiff, sued Howard Jerusalem, who was Secretary of PennDOT, and Alexander Hoskins, the Commissioner of the Streets Department of Philadelphia. And the suit says that the city performed resurfacing, but did not install curb ramps or other sloped areas on the street corners. The court determined that usability should be applied broadly, and their quote was, "The ADA is a remedial statute designed to eliminate discrimination against the disabled in all facets of society. As a remedial statute, it must be broadly construed to effectuate its purposes. Therefore, this court case made the ruling that resurfacing equals an alteration." So now we've established that a resurfacing is an alteration. However, there's a lot of different types of resurfacings. So questions were asked to the DOT and the DOJ, what exactly is meant by a resurfacing? So much so that in July 2013, the DOT and DOJ created and released a joint technical statement that established what is an alteration for resurfacing and also what is considered a maintenance and preservation technique. In December 2015, the DOT and DOJ also issued a supplemental questions and answers, which is very informative, 15 questions and answers on the subject of maintenance versus alterations. When these are combined with the CFR language, you get 3 distinct levels of projects. You get new construction, you get alterations, and maintenance. And it's important, coming from the road design background, is to uncouple your other conceived notions of a 4R project, 3R project, and from an ADA perspective, just consider these 3 types. The other link that's on this screen is a FHWA Q&A page. So a lot of information has been posted to that. Again, that went into the formulation of this manual as well. And again, the past manual is written to summarize the federal source language. So we try not to embellish as much as possible. And again, not everything's gonna be cookie cutter. Not everything's gonna fall cleanly into an alteration or a maintenance project. In those cases, please contact the civil rights section. and discuss the obligations before any work begins. I think we've seen issues in the past where work is commenced and then we're having that discussion on the back end, and it's much easier to have that conversation before work commences so that we can figure out our obligations and plan for it better. So new construction, pretty obvious that new construction needs to meet the 2010 ADA standards or the standards that are in the pass manual. So if you build a new sidewalk, the sidewalk needs to meet the accessibility standards. However, you don't need to chase non-complying systems with that new construction. So for example, if you're building a new sidewalk that ties into an existing sidewalk, if reconstructing that existing sidewalk is considered outside of the scope of the project, you don't need to chase that non-complying sidewalk. And the ProWag has a very poignant statement on this as well. R202.3.2, transitional segments of the ProWag states the following: transitional segments of pedestrian access routes shall connect to existing unaltered segments of pedestrian circulations pass and shall comply with R302 to the extent practical. Again, don't have to chase non-complying systems. So definition of an alteration project comes from the DOT, DOJ standards, as well as from the FHWA. Alteration projects, the pass manual definition is alteration projects include activities such as reconstruction, rehabilitation, resurfacing, widening, and projects of similar scale and effect. So quite a bit of a gamut there. Again, thinking of the 3R, 4Rs, we have reconstruction, rehabilitation, and widening all encompassed in that alteration definition. The DelDOT pass manual also includes a listing and a definition for each of the activities bulleted here. And each one of these, again, come from the federal source documents. These type projects require that new compliant curb ramps be installed, or that you replace existing non-compliant curb ramps or other sloped areas wherever the intended pedestrian route crosses a curb. Maintenance type projects. So the pass manual definition for maintenance type projects, again, comes from the federal source language, and they consist of actions that are intended to preserve the system, delay future deterioration, and maintain the functional condition of the roadway without increasing the structural capacity. So again, have the project types are listed here that would be considered maintenance activities. And again, those all came from the DOT, DOJ, and we include the definitions from the federal language as well in the pass manual. Maintenance projects are not required to add new compliant or replace existing non-compliant curb ramps when the scope of work does not lessen the usability of those items. And one thing that's kind of caused, that I want to highlight, that's caused consternation amongst our update team, but is the federal language, is that multiple maintenance activities may rise to be an alteration. That is the federal source language. When we talked about this and we decided to leave it as is. We didn't want to embellish on that. We didn't want to create something that's too prescriptive or not prescriptive enough. So the best thing to do in these instances is please contact the DelDOT Title II coordinator, and we'll talk through it. It's also important from a department standpoint as well, is that we have some consistency across the state. Don't want items in north to be treated completely different in south. So this slide is meant to be a flow chart of what should be your considerations, kind of summarize the project types, kind of be your considerations of the project types we defined earlier when you have a resurfacing type project. The first consideration is, does my work, is it a maintenance type project or an alteration type project based on the definitions that I gave before? If it's a maintenance type project, you can proceed with the work. If it's an alteration type project, you now need to consider whether any of your work affects any of the crosswalk, marked or unmarked. If you do not affect any crosswalks, you haven't altered the pedestrian access route. Therefore, you can proceed with the work. If you do affect any portion, which comes from the federal source language, any portion of the crosswalk, then you have affected the usability of the system. And therefore, you need to evaluate the curb ramps that is serving those crosswalks. If the curb ramps that are in place at that time, if they're compliant, you can proceed with the work. They don't need to be replaced. If they're compliant curb ramps, they're compliant, don't need to rip out and install new compliant curb ramps. However, if they're not compliant, then we're going to need to install new compliant curb ramps. So the last thing I want to touch on for project type and application of the standards is temporary conditions. So 3 documents on the federal level affect temporary conditions. We have the MUTCD, we have the ADAG, and the ProWag. And of course, they're all treat the issue a little bit differently. The MUTCD, which is a regulatory document, It's codified into Title 23, Part 655, Subpart F. And it states that you must provide adequate pedestrian access and walkways. In addition, it states that any detour route is provided to provide similar accessibility and detectability features. The ADAG, which is also a regulatory document, requires that temporary structures meet the accessibility standards. Working with the FHWA, we determined that temporary boardwalks are considered a structure, and those must meet the accessibility standards. The PROAG, which is a guideline at this time, requires that all temporary conditions meet the accessibility standards. PROAG is a guideline, and what we want to do is follow that as a best practice for now. However, what we're required to do is to follow the ADA standards that's in the ADAG, and as well as the requirements that's in the MUTCD. So Chapter 3, the accessibility standards. So again, tried to break it out. What are the standards? And we have that all included in Chapter 3. And Chapter 3 and Chapter 4 are meant to supplement each other. So we tried to keep the federal source language intact as much as possible. We didn't want to embellish, we didn't want to change. However, we need to make some changes based on the merging of federal language, just for user clarity. Chapter 3, because we wanted to keep the source language intact, meant that it stays in a lot of the legalese writing of regulatory language. And this is where Chapter 4 comes into play. So Chapter 3, to use the design manual, is cumbersome. Chapter 4 is written more like a traditional design manual and will help the user out in that regard. We also use parenthetical citation at the end of each statement in Chapter 3. And the idea here is that the department can determine where the standard it adopted came from. Did it come from the ADAG? Did it come from the PROAG? Or did it come from something that the department created itself? Again, the idea here is the department can go check it if they don't think something is right, or if we're applying it incorrectly. The department chose to format it in a fashion similar to the MUTCD, where the text is broken down into categories of statements. So again, this should make it very clear what's a standard versus what's a guidance, what's an advisory. And this chapter should be used frequently by the civil rights section and engineering support section. It should be used as a reference for the other sections. Again, it's in the legalese language and should be used by those sections and as a reference for others. So we have this slide again, should look familiar. Again, the idea with this slide is to show that the ADAG is the standard, the PROAG is the best practice. And that's how our update treated these guideline documents. So our first step as a team was to look at the difference between the two guidelines documents and the ADAG and the PROAG. So for example, for continuous width, the ADAG requires a 3-foot wide continuous width. The PROAG requires 4 feet. So we started with that baseline. Here are the standards, here's the guideline, and what do we want to adopt as a department? From there, we said whether it should be a standard, what should be the standard, and additionally, if we should adopt some guidance with it. So that's the basis of the spreadsheet. So the spreadsheet was also, it was created, and then we circulated out to the rest of the key stakeholders throughout the department to get their opinion on, and had some discussions about what's in the best interest of the department. So this is a blow up of the standard for continuous clear width, and in this case, discussed it as a group, and we decided that we're going to adopt the PROAG as a standard, but we're also going to include an exception from the ADAG. Another programmatic change that we made is that we wanted to incorporate a design and layout standard versus an accessibility standard and acceptance standard. And the idea behind this, what we're calling the accessibility buffer, that is, if we're held to a 2% maximum from an ADA perspective, and that's the legal requirement, let's build to be below that. So from the really common one is the cross slope of the PAR. Cross slope of the PAR from an accessibility standpoint must be 2%. However, and if that's the case, then what we wanted to do was to design at 1.5%, build in a buffer for account for potential irregularities or variances due to construction methods or materials. And again, the hope is that over time, this will lead to less rip out work and just a better overall application and more user-friendly for the department. This slide shows how the accessibility buffer was built into our standard construction details. So this table comes from the updated pedestrian connection details. And you can see we built in that accessibility buffer. We said what we want to lay out for design for a cross slope. We said we want to lay out for our turning space sizes. And this is what is the acceptability standard. So the standards format, mentioned before, we adopted the METC format. Again, we took a couple options to the update committee, and this is what we thought would be the most clear. So a standard, it's in bold text, and it's a statement of a required, mandatory, or specifically prohibited practice. An exception is listed below a standard. It's an exception to the standard, and it's also bold and italicized. And it's a statement or a location or a condition where a specific standard may not apply. Guidance is italicized, and it's a recommended practice to optimize facility operation. And again, it's recommended. It's not a standard in and of itself. An option statement is a permissive condition that carries no requirement or recommendation. An advisory is just an information statement used to clarify standard, exception, guidance, or option. And the really nice thing about this formatting alternative is that we kept the integrity of the federal language, and the department was able to supplement on issues that we've seen as a department locally with our own language. So table 1.5, this should look pretty familiar. So the current manual has a table 3.1, and the idea behind these tables is to kind of put the accessibility standards into a tabular format. So the issue with that is that people will go to that table and not necessarily go read the accessibility standard, which has caused some confusion. So what we did in the updated manual is we added some language that said, please go read the accessibility standard in chapter 3. And we know people will probably ignore that as well. So we can put in a hyperlink in the table to click on the hyperlink to the standard and go confirm what you're reading. One of the things we tried to do as well is we tried to add as much information from the standard as possible into that table. You know, the information, the standard is a standard, and if you remove or add words from that standard, you can change the meaning. So we tried to keep as much language there as possible to avoid having to misinterpret what the standard is. And again, one thing that we did was we brought this up to the front of the manual. You can see it's table 1.5, so it's in the beginning of the manual, so it should be even easier to access for the user. So chapter 4 is design considerations, and it's used to supplement chapter 3. So design considerations, it's the idea behind it is to put the legalese writing of the regulatory language into layman's terms, and also to apply a typical standard, manual formatting to the language, put it into plain English. It also provides guidance and best practices, which are not necessarily accessibility standards, but by putting it in the manual, our thought is that we remove some of the subjectivity behind these practices and put them in a location in the manual, which is clearly marked as a design consideration. It also divides also a nice thing about chapter 4 is it divides the guidance that's in chapter 3 to be based on facility. So chapter 3, we're kind of stuck in the formatting and the outline of the structure of information from the federal documents. And in chapter 4, we base it on facility type. So for instance, all the information about pedestrian connections is in one place. All the information about sidewalks is in one place. Now we're going to get into a couple of the standards that were adopted with the updated manual. We're going to start with continuous width of the PAR. And what I want you to pay particular attention to as we go through this example is how the language supplements each other. The language that we showed before of the standards, exceptions, guidance, options, and advisories, please make note how they all come together and play with each other. So the minimum continuous clear width that the department adopted is 4 feet. This comes from the PROWAG. And you can tell it comes from the PROWAG based on the reference at the end, the R302.3. The R represents the PROWAG, and you can tell pretty quickly it comes from the PROWAG. The ADAG actually allows a 3-foot continuous clear width. However, the department felt that a 4-foot width was more appropriate to a public right-of-way setting, so we adopted the 4-foot continuous clear width. Chapter 4, again, the nice thing about Chapter 4 is it identifies that what the ADAG requirement is, what the 2010 ADA standards requirement is, and gives you that consideration as well. The department also adopted the pinch point criteria from the ADAG as an exception. So you can see there's an exception here, and it permits that the path can be pinched down to a 2'8" width minimum over a distance of 2 feet maximum, which is the pinch point criteria. So this comes from the ADAG, and you can tell it comes from the ADAG based on the parenthetical citation of 403.5.1. No R, it comes from the ADAG. And finally, we have an advisory on the slide as well. And the advisory is department created. There's no parenthetical citation. and the advisory is intended to give the user additional information on about the standard as well. And so in this case, access routes that are narrower than 2 foot 8 inches will not allow for the mobility device user to pass, and therefore will not be allowed because it's not accessible. A couple of examples real quick to work through kind of how the standards are meant to be applied. So the first example, we have a sidewalk. There's a 3-foot continuous clear width, and there's a utility pole that is for a length along the par of 1 foot 6 inches. So it violates the standard. It's not 4 feet wide. However, it meets the requirements of the exception. The exception allows for a minimum width of 2 foot 8 inches over a maximum distance of 2 feet. Therefore, you met the requirements of that exception. You did not violate the standard. The next example is a 3-foot wide continuous clear width over a 5-foot length. So in this situation, we didn't meet the standard and we didn't meet the exception. Therefore, we violated the standard. However, the information that we have in Chapter 4 provides information about the 2010 ADA standards. So even though we violated the department standard of the accessibility requirement, we need to generate an RPE. We can justify that RPE with the federal accessibility standards because we've met the federal accessibility standards for a 3-foot wide continuous clear width. And finally, we have an example down here in number 3. We have a 2-foot wide, 2 foot 6 inch wide access route, and that's not allowable. Mobility device user cannot pass through that distance, therefore not going to be allowed. So keeping with continuous clear width, this is where the standards and the guidance comes into play to supplement the standards. So a couple of guidance statements on this slide. One thing I wanted to note is that the department did not adopt language for shared use pass in Chapter 3. Instead, we put that information into Chapter 4. So shared use pass should be 10 feet wide, except when in accordance with the AASHTO bike guide, where it can be pinched down to 8 feet. So the department's guidance on sidewalks has changed a little bit. For low volume facilities, our guidance is that provide a 5-foot sidewalk minimum. However, if there is no buffer provided between the back of the curb and the sidewalk, so no buffer strip, we want to increase that width to a 6-foot wide width. And this is consistent with the current AASHTO practice. Another thing that we've added is that for high volume facilities, for sidewalks, we want to design that in accordance with the highway capacity manual. So we make sure we have sufficient width for the high volume locations. It also should be noted that the pedestrian access route, there shouldn't be applications that are below 5 feet. However, if you do go below 5 feet, there is an accessibility standard that you provide passing spaces. Those passing spaces are 5-foot by 5-foot areas, and they should be located 200 feet maximum from each other. And again, you shouldn't have that issue with the department designing applications for 5 feet and 6 feet. So continuous clear width through the medians and pedestrian refuge islands. So we adopted the PROAG standard of a 5-foot continuous clear width. And the reason for that is that 5-foot width allows mobility device users to pass each other inside of that refuge island. Also adopted two guidance statements that go with this. And one is that the width through the island should match the approach pedestrian access route. If you have a shared use path that's approaching the median, then you should make that width through the median the same width as the access route, so 10 feet. Additionally, we captured the practice of providing additional 2 foot in width along channelizing islands where pedestrian signal poles be placed. And the reason for that is it provides more flexibility to place that pedestrian signal pole. That's a practice that the department's been using, and we kind of incorporated that into this manual. And Chapter 4 summarizes all this information as well. So that 2 foot width, you can see the red arrow here on the slide. So that would be the minimum width. So this is a 5-foot sidewalk. We'd add 2 feet onto that, and we'd get to our 7 foot through the median. We accounted for this practice in our standard construction details as well. We put a note to that effect. So the standard construction details includes the guidance. We want to try to meet that guidance where we can. So the standard construction details incorporates that guidance. So we mentioned that we updated the width of sidewalks. So sidewalks we updated from 5 feet into 6 feet for some locations where there's not a buffer. And so we accounted for that in the updated standard construction details. we added in a note that said that essentially that practice, if there's no buffer, please make it 6 feet wide. Again, our details are going to contain what we want to do. Additionally, you can note that we incorporate that accessibility buffer into our details as well. We removed the 2% maximums and put in the 1.5% design cross slopes and layout cross slopes, for example, to try to get what we want and give that kind of accessibility buffer on the back end. A couple other changes, that accessibility buffer has been kind of distributed throughout the standard construction details. So wherever it said 2% max before, change that to 1.5%. Wherever the running grade, for example, was 5% max, we changed it to 4.5. Again, try to create that buffer during the design phase. Change the sidewalk width. So for example, in the bus pad details, sidewalk would defer to standard M3, which is for sidewalks, or to the plans. We removed that 5 foot, and so that way in the new details just refer to M3. And we also created that accessibility buffer by removing that 2% max, leaving it as 1.5%. And the other thing to note with the bus pad detail is that we removed that 3 foot dimension as well from the back of the sidewalk, and we left the 8 foot min dimension. The 8 foot min is a accessibility requirement, so we left that in there, and also it allows for variations in the sidewalk width. A couple other standards that we're going to go over, the grade of the par, the running slope. So departments are going to most typically perform work in the highway right-of-way. So the standard at the top is within street or highway right-of-way. That should be the department for the most part. And in those cases, the running grade should meet the general grade of the highway, the adjacent highway. Outside of the right-of-way, you're held to a 5% maximum. And then we also have a criteria for pedestrian street crossings. And the pedestrian street crossings criteria is a 5% maximum, and the department adopted a 4.5% design standard. And so the road design folks out there are saying that my E-max the department allows is 6%. So that's a violation. We can't build up to that E-max. So a couple of thoughts on this is, one, the road design manual allows for 4% in an urban area. So the 4% would be below that 4.5%. And in addition, you shouldn't have those sharp E-max curves right at a sidewalk at an intersection usually. And then finally, the most important part of this conversation is about project scope. Remember in chapter two discussion, we talked about alterations. So if you have an existing facility, you're required to meet the ADA standards to the maximum extent practical. If that means not changing the cross slope of the road, then that's part of your project scope and project requirements. You don't have to chase that. So the cross slope of the par. Essentially the cross slope of the par is 2% maximum. Department adopted a 1.5% design cross slope. And the thing that affects the cross slope is the traffic control present. So if it's a pedestrian street crossing without yield or stop control, i.e. a signal, and traffic is permitted to flow through the facility, then we're allowed to go up to a 5% maximum. However, again, we adopted a 4.5% design standard. Mid-block crossings permitted to match the general grade of the street. And one thing else to note about this is the cross slope requirements that apply to just the par, not the pedestrian circulation path, to the entire pedestrian circulation path. An advisory that comes from the ProWag states the following: where sidewalks are wider than 4 feet, and the portion of the sidewalk is required to comply with the requirements of R302.3 through R302.7. So again, it's just the par. So cross slope requirements, if you're going across a driveway apron, the cross slope requirements apply. It's a sidewalk, the cross slope requirements apply. So the application on this slide would be a violation. You have the apron that's not depressed, have a flat apron. Instead, you have a warping on and a grade break inside of the par. And so when you go out and measure this, you're taking that 8-inch curb and you're transitioning that height difference over that 5-foot sidewalk, and you have a slightly higher than 10% cross slope on that driveway entrance. So that's not allowable under the ADA. You can see this is the picture on the top left corner here. That comes from the FHWA, and it shows the accessibility challenges that are associated with this type design. So our standard construction detail shows the proper treatment, and that is you have a ramp, and it flattens that whole sidewalk area inside of the driveway entrance. Entrances are designed more like a pedestrian street crossing, so everyone knows this location out here in Dover. So in this location, you have a high volume entrance, and it's designed with return curbs. This application should be treated more like a pedestrian street crossing. In that case, you're allowed to have, as long as there's no, based on the yield and stop control, you're allowed to have up to a 5% cross slope. So cross slope at par. Again, you have this picture shows a ramp slope, City of Milford, that goes up quite a bit into the pedestrian access route. And you can tell how far that ramp slope goes, that there's not a sufficient location for the cross slope of the par to go across. So the user that's continuing along the network will not have an adequate pedestrian access route based on the cross slope. Transitional segments. Mentioned this a little bit before. So a compliant pedestrian access route that adjoins an existing non-compliant route will have to transition the width as well as the cross slope to that of the non-compliant an existing pedestrian access route. So in order to do that, the department has historically used a 5-foot transition slab that's been in our curb ramps details as well as our pedestrian connection details, and we've called them transition slabs. There was no standard transition cross slope requirement. But the department adopted some guidance for this of a 3% per linear foot transition rate. This is consistent with what other DOTs are using, other user agencies. This is not an accessibility requirement, but does kind of try to fill the void of what is a best practice. So that way we're not guessing. Additionally, we kept the 5-foot transition length that's shown in our standard details. And the reason why we did this is consistent with our specifications. And also, if you combine that 5-foot length with that 3% transition rate, you multiply it out, you can have a 15% cross slope transition between those two pedestrian access routes. So that's very steep, shouldn't occur very often, and most likely it'll be from like a 2.5% to 1.5%. So it's much more gradual, but we are allowed to use that flexibility up to that 3%. And this is a note that we added to the standard construction details as well to kind of state that practice. So again, 5-foot transition slab where we're meeting an existing sidewalk with our proposed sidewalk. And we state that we want to have not to exceed a 3% per linear foot of transition rate. So pedestrian street crossings. Pedestrian street crossing occurs anywhere the pedestrian leaves the approach sidewalk or shared use path and enters the street. They're typically called crosswalks, and they can be either marked or unmarked, and it's not an ADA requirement of whether they're marked or unmarked. It is also important to note that R204.3 of the PROAG specifies that pedestrian street crossing is essentially required whether there are departure and arrival pedestrian access routes. If there is no connection across the intersection, then you don't need to provide a compliant pedestrian street crossing because one isn't present. The crosswalks themselves create conflicting movements between pedestrians and vehicles. So it's important that they be designed to be clear, predictable, and visible both to the driver as well as to the pedestrian. EWS are also required, and we'll discuss that more later. And skewed crossings, this is included in Chapter 4, try to give some guidance on preferential treatments, not an ADA standard. Skewed crossings create greater exposure time to pedestrians, reduce operational capacity, and create additional accessibility challenges. Therefore, we want to try to avoid skewed crossings where possible. However, skewing a crossing may be preferable to putting a crossing in an unpredictable place for the driver and can create safety hazards. And finally, we shouldn't do kinked alignments where we don't have a channelizing island to perform that kink over. And the reason why it's very hard for the user the visually impaired user to ascertain where they're going. Operable parts. So an operable part is defined by the U.S. Access Board as a component of an element used to insert or withdraw objects or activate, deactivate, or adjust the element. So more in layman's terms for us, that means they're pedestrian push buttons, parking meters, and transit kiosks. Operable parts from the accessibility standpoint require two things. One, it requires that a 48 by 30 inch clear space be coordinated with the operable part. It also requires that the operable part be reachable with one of the reach ranges specified in section 3.7. And reach ranges can either be side reach or forward reach, and they can be either obstructed or unobstructed. Again, the two requirements are clear space as well as the reach range requirement. And the images on this slide, they come from the 2010 Anthropomorphology of Wheel Mobility Device Users project. And it really clearly shows the reachable reach ranges and why they're important. You can see the percentage of people that are on the slide that can reach inside of those little boxes, and shows you how users are actually reaching for those operable parts. So side reach unobstructed. The department's preference for all push buttons is for unobstructed side reach. So unobstructed side reach requires a maximum mounting height of 48 inches and a minimum mounting height of 15 inches. In addition, the other key requirement is that 10-inch horizontal distance between the clear space as well as the operable part. And the department's practice is that any surface that does not meet the surface requirements of section 3.1.5, so the firm, stable, slip resistant, would be treated as an obstruction. So in other words, between the sidewalk and the push button, you would have 10-inch maximum for it to be considered a unobstructed side reach. In the bottom left-hand corner of the slide, we have the Department of Standard Construction Detail T18, which specifies the mounting height that we're requesting. And the mounting height with this update has been updated to be from a 38-inch minimum to a 46-inch maximum. And the reason we did that is it offers greater flexibility to the department on the back end, and we'll talk about that a little bit more additionally. So in addition to unobstructed side reach, we have obstructed side reach. Should not ideally occur within the public right-of-way. However, it is an alternative and is considered accessible where it has to occur. There are two acceptable alternatives for obstructed side reach. The one that we'll use most often is alternative B in this figure. And essentially what happens in alternative B is that the 10-inch horizontal distance gets extended to 2 feet from the clear space, provided that you meet the new height requirements of 3'10" max and 2'10" max. And again, this is not the department's preferred alternative. Forward reach, where you can only reach for a operable part from a forward approach, you have to use forward reach. Again, not the department's preference, but it is allowable. And so in this case, the requirement is that the operable part be mounted between a height of 4 feet maximum to 15 inches minimum. And there's two other things to consider with this is that one, the operable part, the vertical projection limit needs to be mounted in a way so it's flush with the ground surface, the finished ground surface. And also, if we're only able to approach from a forward approach, we need to consider any required turning spaces for the user that's on the route. Forward reach obstructed. So this is more for buildings. So the figure here from the ADAG is for a counter. So again, you have your height limits and you have your projection limits. Shouldn't occur very often in the public right-of-way. However, if it does occur, it is permitted. And the other key consideration with this application is we need to consider the knee and toe clearance, which we'll talk about here in a little bit. Again, the same advisories as the previous slide apply. You need to consider the vertical projection of the operable part extend all the way to the clear floor, ground surface, and also consider any required turning spaces. So clear space. Definition of the clear space is a clear space. The Access Board does not give any more information on that. They give some technical requirements, which we'll go through right now. So the surfaces of the clear space shall comply with section 3.15, the firm, stable, slip resistant. All surfaces of the pedestrian access route are required to comply with that section. And it also requires that there be a cross slope of 2%, which again is the rest of pedestrian access route. So the takeaway from that requirement is the clear space can occur anywhere on your pedestrian access route. The size requirements, it requires a 30-inch by 48-inch minimum. So we talked about that before. The department also incorporated a guidance here to try to provide accessibility for more users. The position, it needs to be specified. It needs to provide for either a forward or side approach. Then we have some more requirements here about how it's situated with the PAR and also additional maneuvering space. If it's confined, we need to provide a larger area for that maneuvering area. So coordination with the operable part. So the image on the left here shows the operable part being reached for in the image on the left with a unobstructed forward approach. You can see the coordination of that clear space with the operable part. The middle image, this shows the knee and toe clearance, why it's important for an obstructed forward reach. And then on the far right, we have a side reach, unobstructed side reach. And a couple things to note here is that that clear space can be offset 10 inches from the operable part and it still be considered an unobstructed side reach. Additionally, it can be offset 2 feet and be considered an obstructed side reach, provided that it meets the height requirements of that reach range. So one concept that I wanted to kind of give you here is that again, the requirement is a clear space for the operable part. It's not a turning space. However, in this slide, we have a user that's outlined in red, 30 inches by 48 inches for the clear space, and we have the operable part in yellow. So if the user has to use that operable part and turn at that location to continue on the pedestrian access route, what happens is that box turns into a 48 by 48 inch turning space. So again, turning space is not required. However, you need to consider the pedestrian's movement at that operable part, because there may be a requirement to provide a turning space depending on how it's laid out. So as previously mentioned, we updated the DelDOT Standard Construction Detail T18 as part of this effort. And why we did that is try to provide more flexibility to the department. So mounting heights changed. The new mounting height is now 38 inches to 46 inch max. And the reason why is that that mounting height allows for it to be considered either a unobstructed side reach or an obstructed side reach. That said, we still want an unobstructed side reach for each pedestrian signal pole. And the details state this as well. The details state we want this to be 10-inch maximum from the pedestrian access route. And we also added a note as well that specifies that if it's only accessible from a forward approach, that we need to extend the clear floor or the ground surface all the way to the vertical projection limit of that operable part. So now we start to leave the accessibility standards. The accessibility standards are just for the reach range and clear space. Now we're getting to the MUTCD. There is no mention of pedestrian signals or push buttons in the ADAG. However, the PROAG specifically says shall comply with MUTCD. However, if you get to the once you get to the MUTCD, section 408 pedestrian detectors has all the requirements for where the pedestrian signal should be placed as a should condition. It's not a standard, it's a should condition. And these are all the requirements that are on the screen. And again, it should meet all the following criteria, and the key word being should. Again, we've left the accessibility standards and we've now moved into the MUTCD should conditions. Figure 4E3 summarizes the guidance that was written on the previous slide and gives you recommended locations where that pedestrian signal can be placed. Again, you look at the hatching and it says recommended. Figure 4E4 of the Delaware MUTCD provides acceptable locations for mounting. And again, you need to consider how the user is going to reach for that pedestrian push button when they're approaching that pedestrian push button, whether it's a forward reach or side reach, and how that clear space is coordinated. The MUTCD requires that the pedestrian push button be placed, or it doesn't require, it says it should be placed parallel to the pedestrian street crossing. And so that comes into play where we see the recommended versus not recommended arrows in here. So again, the important thing for this is to consider how the pedestrian is reaching for that push button. So accessible pedestrian signals are used to communicate information about the walk, don't walk signals at at intervals that signalize intersections in non-visual formats. The ADAG is silent on this practice. However, the ProWAG has two sections on this, 209.1.1 and 209.2. And so the ADAG guidance was not incorporated, or I'm sorry, the ProWAG guidance was not incorporated into the manual. And the reason why is the department currently maintains interim guidelines for the installation of accessible pedestrian signals. So what was not incorporated was the statement that where pedestrian signals are provided at pedestrian street crossings, they shall include accessible pedestrian signals and pedestrian push buttons complying with the MDCD. Additionally, for alterations, that ProWAG stated the following: existing pedestrian signals shall comply with 209.1 when the signal controller and software are altered, which is different. Again, this is different than the interim guidelines that the department has. And the manual essentially just kicks you over to the department's interim guidelines. So the department's interim guidelines requires three basic conditions be met as determined by DelDOT traffic in order to install an APS. One, the APS must be requested. Two, the intersection must be signalized. And three, retrofitting the signal to include APS must be feasible. Again, not included in the updated pass manual. So now we're going to talk about street level pedestrian connections. And we're going to spend quite a bit of time on that today. So wanted to first address the term pedestrian connection. When we created the term pedestrian connection, it was not meant to be a replacement for curb ramps or blended transitions. Instead, it was kind of made as a substitute to the CFR language I showed you before of a curb ramp or other sloped area. The term curb ramp and blended transition is a federally defined term, and so pedestrian connection does not replace them. This slide shows you the hierarchy. All curb ramps are pedestrian connections. Not all pedestrian connections are curb ramps. So pedestrian connections can either be a curb ramp or a blended transition. Curb ramps can either be laid out to be a parallel type curb ramp, a perpendicular type curb ramp, or a diagonal type curb ramp. And those types can be combined to be into a combination type curb ramp. Additionally, we have blended transitions. And the blended transition can either follow the same layout as the curb ramps that were just highlighted, or they can be depressed corners or raised street crossings. And street level pedestrian connections are typically installed at intersections, mid-block crossings, accessible on-street parking, passenger loading zones, and are used to really transition the elevation of the approach, sidewalk, or shared use path to that of the street crossing. Street level pedestrian connections, again, comes from the Code of Federal Regulations and meant to replace the term, the CFR language of curb ramps and other sloped areas. The barrier, the curb itself, acts as a barrier to the user. And so we're trying to remove that barrier. The requirement that's in the ADAG and the ProWAG, as well as the MUTCD, that we adopted the ADAG language, is that the pedestrian connection be entirely or wholly within the pedestrian street crossing. So the issue on the screen here in the picture is that the pedestrian street crossing comes up and there's a curb in the way of the pedestrian street crossing. Therefore, it's not considered ADA compliant. So as I mentioned, curb ramps and blended transitions are defined federal terms. A curb ramp is a pedestrian connection that has a slope segment that exceeds 5%. Blended transitions are street level pedestrian connections where the slope segment is below that 5%. So the difference between them is the slope of that running the segment that's meant to bridge the elevation difference. The figure on the left side of the screen comes from the updated standard construction details, and the figure on the right side comes from the current ProWAG. So perpendicular type curb ramps. So curb ramps can be laid out in multiple ways laid out in multiple orientations, which creates the name of the different types. So you have perpendicular, parallel, and diagonal. The screen shows an isometric view of a perpendicular type curb ramp. And a perpendicular type curb ramp, the key part of that definition is that it has a running slope that cuts through or is built up to the curb. So anytime that you're cutting through the elevation of the curb at an angle, that's considered a parallel or perpendicular curb ramp. And the thing that I want you to note here is how the pedestrian access route is coordinated with the curb ramp. So it's coordinated at an angle, and they come up to the top of that curb ramp. In order to get to the ramp segment, they have to make a turning movement to enter the ramp and into the street crossing. So important thing to note here is that you see a flared side and also a return vertical curb on that curb ramp. You can never have those features on a parallel curb ramp. If you have the option to have a flared side or a turn curb, it's a perpendicular curb ramp. So the advantages of perpendicular type curb ramps. One, it doesn't have a turning space at the street level pedestrian connection, which means that water that's running along the street has less opportunity to get into the curb ramp and accumulate and pond and create sedimentation. The street level pedestrian connection can be aligned to provide directionality to the user, and motorists can easily determine which direction that the pedestrian is trying to cross. Again, crosswalks create conflicts between the vehicle and the pedestrian, so it's important that we lay them out to be clear. Disadvantages, they require additional width to the pedestrian circulation path that's approaching, so they're a little bit larger than a parallel type curb ramp, and large radius type applications can create some difficult designs, but we'll give you some techniques today to try to mitigate that. A couple of figures of perpendicular type curb ramps. Again, the key part of the definition is that the curb ramp itself is built up at an angle and cuts through the elevation of the curb. So each one of these figures, you can see that the ramp is at an angle with the curb. And you can see also that all these alternatives provide an option for a flare or a return curb. Parallel type curb ramps are the next curb ramps we're going to talk about. Parallel type curb ramps have a slope segment that's in line with the pedestrian access route and brings the user down to a location where they need to turn in order to access the pedestrian street crossing. So parallel curb ramps, again, will never have the flared side or the return curb as part of its assembly. And the other key thing is to think about is that the user is going to come down that ramp and then make a turn to enter the street. And on the back of that figure, you can see there's a curb that bridges the turning space in the ramps. And that curb is used to, it's not required, but it adds a detectable feature for the visually impaired and also helps with soil retention. Advantages of parallel type curb ramps. It requires minimum circulation, approach circulation path width, which is ideal for constrained locations. The ramps can be easily lengthened when required to chase grade. We'll talk about that a little bit more later today. Enhances detectability for the visually impaired user. And if you think about it, the visually impaired user is hit with two cues here. One, they hit a ramp segment, so they know they're going down somewhere. Then they hit that level turning space, and they have the DWS there to assist them as well. Whereas they don't get both of those features on the perpendicular type ramp. Disadvantages, it requires a user who is not accessing the pedestrian street crossing to traverse several ramps in order to get to where they're going. And then the other disadvantage is they can more readily accumulate water. That level turning space is located right at the street crossing. And so you have your water running on the curb typically, and it allows for water to more easily enter into that level area. Two configurations of parallel type curb ramps on the screen. Both of them are on a radius. That's perfectly acceptable. The image on the left has full height curb between the two curb ramps, and the image on the right has depressed curb or a lower curb between the images. So you can have a shorter ramp length accordingly because you don't have as high of an elevation difference to branch. Now we're going to start getting into some fun. Diagonal type curb ramps. Diagonal type curb ramps are laid out very similarly to that of a perpendicular type curb ramp. The key difference between diagonal type curb ramps and perpendicular type curb ramps is that diagonal curb ramps serve two independent street crossings. Perpendicular curb ramps only serve one. Additionally, diagonal curb ramps are typically located on the apex of the corner curb return. So the first bullet here is the department's definition of a diagonal curb ramp. So two street crossings and also at the apex of the curb return. The second bullet is the only reference that's included in the draft ProWag to diagonal curb ramps. The previous definitions that we gave you for parallel and perpendicular type curb ramps came right from the ProWag. The ProWag does not define sufficiently what a diagonal type curb ramp is. And why this is important is that the ADAG, the 2010 ADA standards, which is the standards document, provides additional technical requirements for diagonal curb ramps. Therefore, it's important that the department creates a definition for diagonal curb ramps so we make sure that if we install a diagonal curb ramp, it meets the accessibility requirements. So overall, diagonal curb ramps are strongly discouraged, and I think we know the reason why is it doesn't serve either alignment well. The street crossing, it pushes the pedestrian out into the middle of the intersection essentially. It's difficult for the visually impaired mobility device users, and it's also difficult for motorists to assess which direction the pedestrian is planning on crossing. So as I mentioned, the department had to create their own definition for diagonal curb ramp from the standards document as well as the guidelines document from the access board, which are kind of the accessibility gold standard, didn't have these definitions. So instead, what the department did is we looked around at what other user agencies are defining as a diagonal type curb ramp, and also other federal publications and organizations, and said, what are they defining as a diagonal type curb ramp? So on the screen are several excerpts from the top ones from the FHWA. We have AASHTO, which is made up of all 50 states. And you can see their definition is very similar to our definition. Basically, apex of the curb, 2 street crossings. We looked at previous access board documents. And again, the access board is the federal group that wrote the ADAG as well as the PROAG, and they had some documents previously which provided some insight into their definition. So the 2001 PROAC, the final report, provided this statement, and basically it calls I like this term, calls the diagonal a shared curb ramp. And the reason it's shared is it has two street crossings. And additionally, the 2002 PROAG, which is several iterations before the current PROAG, had a similar definition. So therefore, the department feels pretty comfortable in the definition that we adopted for diagonal curb ramps. One, it's commensurate with other user agencies. It meets the FHWA and AASHTO's definition, and also meets previous definitions that are published by the U.S. Access Board. So just to summarize, one of these curb ramps is a diagonal curb ramp. One of them is a perpendicular curb ramp for directionality. And the key here is they're the same exact configuration. The only difference is the street crossings. The one on the left has two street crossings. The one on the right has one. One with 2 street crossings is a diagonal curb ramp. And the one on the right is a perpendicular curb ramp with poor directionality. And the one on the right is not preferable based on a directionality standpoint, but we'll talk about that more later today. Last type of curb ramp, I mentioned this before, is the 3 of perpendicular, parallel, and diagonal can be combined, and the term for this is a combined curb ramp. So basically, a combined curb ramp, it has an inline ramp that takes the user down elevation-wise to a turning space, and the user can then turn in that turning space to access a perpendicular type curb ramp and go to the street level or to the street crossing. So blended transitions, talked about the different curb ramp types. Now we're going to talk about the different blended transition types. So again, think about the definition I gave you before. And the key criteria is that 5% slope, the running slope of the slope segment. So if you have a parallel type ramp that has a running slope of 4.5%, it's going to be considered a blended transition. The other type of facilities that you can have are depressed corners. So depressed corners are essentially, they're self-explanatory. You depress the corner in order to have access to both the pedestrian street crossings. And finally, we have a raised street crossing, which aren't very common in Delaware, but it's essentially a speed table or a speed bump where the pedestrian access route is carried across the raised street crossing and kind of acts as a traffic calming measure as well. Again, not very common in Delaware. So depressed corners, the name is kind of self-explanatory to what they are. They depress the entire corner for a pedestrian to access the street crossing. So the 2 images on this slide come from the updated standard construction details. And the image on the left is actually, again, from the PROAG. And the idea behind the image on the left is that the sidewalk wraps around that whole corner. And at the top, where it's starting to turn, it can be used as a turning space to enter that blended transition at the bottom. And then on the right side, we have 2 parallel curb ramps that come down to a common turning space. The user can use that turning space to either turn and align themselves with the pedestrian street crossing, or they can continue on the sidewalk. And again, the idea behind this is the depressed corner depresses that entire corner area to that of the street so they can access the street. So depressed corners. So they're better at parallel curb ramps at alleviating drainage. You have a little bit more flexibility on the slope. You're allowed to have a 5% slope where it intersects the street to try to prevent water from accumulating into the lower area. There's no turning space required, but there's no turning movement required. They can be used at locations where it's not large enough to provide separate street crossings for each curb ramp. And the geometry and accessibility requirements are ideal retrofits for diagonal curb ramps. And we'll talk about that more a little bit later. Disadvantages, poor directionality. You see from the last slide, there really isn't much in terms of detectable edges of the depressed corner to align the user. The boundary of the sidewalk and street is much more difficult for a person with disabilities to detect. They're more difficult to drain than perpendicular curb ramps. Again, perpendicular curb ramps has that ramp segment that abuts the curb, so more apt to prevent water accumulation. And depressed corners also can encourage users to go over that corner return because they're depressed. So if they want to go quickly, they can traverse that corner depressed area more easily than having a curb ramp with a curb keeping somebody out. And finally, it's difficult for motorists to determine which way that the pedestrian is intending to cross. Raised street crossings, gave you the definition earlier. It's basically a speed table that's inside of the pedestrian access route. And it basically allows the pedestrian to cross the street on top of a speed bump or a speed hump. So it is there is an application in Delaware. This is down at the outlets in Rehoboth. You can see it looks just like a traditional speed bump with a pedestrian access route that's in brick on this slide crossing the roadway. So now we're going to look at a couple applications to really understand the difference between the types of curb ramps I defined and the different types of pedestrian street connections. So this application is paired perpendicular curb ramps. So call them paired perpendicular curb ramps because there's two curb ramps there serving two different street crossings. And please note between the curb ramps, we have a curb as well as some grass to try to separate those two crossings. This application is one curb ramp serving two pedestrian street crossings. This will be considered a diagonal curb ramp. The application on this screen is two parallel curb ramps. You have a ramp segment that's in line with the pedestrian's travel, takes you down to a level area where the person can turn and enter the street crossing. And again, the paired concept. There's two curb ramps here serving two independent street crossings. Depressed corner. This is something that we're added to the details for the updated details. And you can see the whole corner is depressed inside of the pavement markings. And it allows, you have a slope segment coming down to that shared depressed area and lets the user turn and access either the pedestrian street crossings. And you can see from this next slide why that'd be an ideal application to replace a diagonal curb ramp. Basically, it flattens out that whole area. So again, this slide, two street crossings coming up to a single curb ramp. That's a diagonal curb ramp. So the application on this slide is going to be, I'm sure, going to be a little bit difficult for some people. So as Oz answered the other day, it's a type 1. But in all reality, based on our definitions, it's a perpendicular curb ramp. And the reason that makes this difficult is think about the definitions I gave you earlier. A perpendicular curb ramp has a ramp segment that cuts through the elevation of the curb. So it meets the requirement of perpendicular curb ramp, the definition. And you think about the definition of a parallel type curb ramp. Parallel type curb ramp has a ramp segment that's in line with the pedestrian access route. So again, the ramp is in line with the pedestrian access route. So kind of meets the requirements of both. So what we did as part of this update is we did some research into what entities are calling parallel curb ramps and perpendicular curb ramps. And we also reached out to the US Access Board who wrote the standards and got some guidance on this as well. And the easiest thing that I'm going to summarize with you and try to emphasize earlier is if it can have a flared side or if it can have a return curb, then it's going to be a perpendicular curb ramp. So in this application, you could put in a flared side on the side of that curb ramp or a return curb, and it would still be acceptable. Parallel curb ramp, you could not. So for all intents and purposes, we're going to call this a perpendicular type curb ramp. And we're also we're going to call this perpendicular type curb ramp. You have another perpendicular type curb ramp. And again, the key feature here is whether you have a street crossing or not that's going horizontal to the screen. We definitely have one vertical, but since there's not a street crossing going across the road, the main road here, it would be considered a perpendicular curb ramp with poor directionality. Now we have a combination curb ramp. So you can see the user approaches the pedestrian connection. There's a slope segment that comes down to a common turning space. That's a depressed area. The user turns there, and there's another curb ramp taking the user out to the pedestrian street crossing. So you use a parallel curb ramp in combination with a perpendicular curb ramp. And these are really good and great chasing scenarios. So now we have, well, what is it? So the left side of the screen is pretty clear. It's a parallel curb ramp. I have two parallel curb ramps coming down to common turning spaces. The right side of the screen is a little bit more complicated. And the reason I wanted to share this one is that this, when we discussed with the FHWA, this is what they pointed to as a depressed corner. And you can see the corner on this area is depressed, has a turning space that's level, that serves both the ramps coming into it. So that application would be considered a depressed corner. So if all applications that meet the standards in the manual are considered compliant, ADA compliant. So all curb ramps and all blended transitions that meet Chapter 3 requirements are compliant. However, there are some that are more preferential than others. And we get into the preferential items that are more subjective. So on the x-axis here, we put some subjective criteria down for directionality, edge alignment, predictability of the vehicles, location of the waiting area, positive drainage potential, comfort for user not assessing the street, and required footprint. On the y-axis, we put the different types of pedestrian connections. And then we assigned most preferential to least preferential, preferential for each one of the applications. And again, these are all subjective. If you were to argue with me that one of these should be yellow when I have it as green, that's fine. I'd probably agree with you. But the overall consensus here from this slide, the takeaway is that perpendicular type curb ramps are generally preferable to the other types of pedestrian street crossings or pedestrian connections. So to document what the department's preference is, and again, try to remove some of the subjectivity from this, is we made a new section to Chapter 4, Section 4.5.2, and we stated what the department's preference is in terms of what we want in terms of different pedestrian connections installed. Again, try to remove the subjectivity. All applications that meet the standards in the manual are considered ADA compliant. That said, if we can go above and beyond and provide something that has additional usability, that's great. That's what we want to try to do. So the first goal should be to create a one pedestrian connection per street crossing. If we have 2 street crossings, we should provide 2 different pedestrian connections. And we want to create them separate and give some sort of directionality to them and sort of edge line alignment, like we said. So to create that separation for perpendicular type curb ramps, we can add that separation that we saw in the city of Dover with the curb and the grass between the curb ramps. And then for parallel type curb ramps, we can add some distance between them. Try to space them out. A general rule of thumb is space them out by about 4 feet to create that separation. Again, as I mentioned before, the department decided that perpendicular type curb ramps are generally preferable to the other types of applications. However, parallel curb ramps are preferred at the following 2 applications. Constrained locations that preclude the ability to construct perpendicular type curb ramps. So again, perpendicular type curb ramps have a larger footprint. And if we can't install a perpendicular curb ramp without hitting other constraints, let's put in a parallel type curb ramp. They're perfectly accessible and meet this ADA standards. Another location is a location where we have steep approaches. We're going to talk about the chasing grade requirement later today, but if you're chasing grade on a perpendicular type curb ramp, that means that the ramp segment is pointing you out to the street, and you're going to have a steep ramp segment, so a 10% ramp segment throwing you out into traffic. In those cases, from a safety standpoint, we'd want to put those steep ramps on a parallel type, so you come down to a common turning space, which is going to be more level to stop somebody and wait there rather than throwing them into traffic with that steep slope. Depressed corners are acceptable, but should be considered after the use of perpendicular and parallel type curb ramps. And then finally, we have diagonal type curb ramps. Again, we talked about this before, diagonals don't serve either user well. However, they're allowed on alteration type projects. And you should talk to the Office of Civil Rights before installing these and get permission from the Office of Civil Rights. So I think this is probably a good spot to go to a break, John. Do a 15-minute break. Does that sound good? No, we're a little bit ahead of schedule, so. Yeah. So what we're going to do is we're going to have a couple survey questions. See who is paying attention at home or in the office these days. So the first survey question is, at what minimum continuous clear width is an RPE required? And again, you have the instructions at the top of how to go online and answer the question, or you can text it in. Seeing the answers coming in, we got 2'8", 67%. No answers for 3 yet, that's good. 2'8" is really starting to accumulate, awesome. All right, so the answer to this one is, it's kind of a twofold question. Let me wait for a second. See if response is still coming, I'll wait. Okay, I think we're starting to stabilize around the 80% mark. So it's based on the standard as well as the exception. So the department standard is the ProWAG standard, 4 foot. Then we have the exception of 2'8". So it depends on your maximum length that obstruction is. So go back to the examples we had before, that 1'6", for a 2'8" dimension, perfectly acceptable. Don't need an RPE. However, if that extends to 5 feet, like that 5-foot step, then you're going to need an RPE. So good answers, kind of a trick question off the bat. Another kind of curveball coming from the road design aspect is, which of the type of the, which someone's very eager on this one. Which of the following are not one of the types of federally recognized ADA type projects? We have new construction, reconstruction, alteration, or maintenance. So we had one person answer maintenance. Reconstruction is gaining some steam. And again, the guidance that I gave earlier is, please throw out all the other notions you had about project types that you've had and just consider the types that we talked about in the past manual as well as today. 84% still for maintenance. Seeing some shifts, 80 and 20. Not much is changing, so I guess I'm going to go ahead and answer it. So the answer here is, reconstruction is not considered a project type. Reconstruction is included in the definition of an alteration. Maintenance type projects are considered a project type that from the guidance that was issued by the DOJ and DOT. So now I see reconstruction going up a little bit after we gave the answer. So that's good, at least you're listening. All right, and with that, you want a 15-minute break? 9:50, come back at 9:50, and we'll restart from there. Okay, thank you. Awesome, welcome back. It's 9:50. I want to remind everybody real quick that the Q&A is open. We have Tom Nickel here, Rob McCleary, and Jansen. They're all lonely. they want some questions to come in so they can answer. So please keep them entertained for us. So welcome back. Appreciate you sitting through for the first part. A little bit ahead of schedule, so hopefully get you out of here a little early today. So starting off with the updated standard construction details. Should have been distributed out recently, and some of you have been involved in the update process itself. But when we started looking at the accessibility standards on a federal level and trying to meet the federal requirements, kind of noticed that there are some items in the current details that were not jiving with the federal standards. And so what we could have done was made some small minor changes here or there to the details. We floated around some ideas that way. What we eventually decided to do was to kind of restart the details and kind of build it back up from the understanding of a parallel, perpendicular, diagonal type curb ramps and depressed corners, kind of how the manual's laid out and kind of how they're evaluated on a federal level. So that way we're all in unison, we're all clear what the requirements are. So this is sheet 1 of the new updated standard construction details. There's gonna be 7 sheets, completely redone, and should make for an easier implementation or easier workflow. One thing I want to note is that there are currently 5 types of standard construction details for curb ramps and pedestrian connections. We kept those 5 types, and the reason for that is to make it easier from the specification standpoint and pay items. And we'll show you how those types align with the updated parallel perpendicular terminology. So this is the first sheet of the updated details, and the idea is that this sheet is supposed to be a general sheet that applies to all sheets. A couple things to note: in the top right, there is a legend sheet or a little legend that goes with the details. So that way it reduces the clutter on the sheet. So if you're looking at an application, you say, what is this TS? You can go over to the legend and say it's turning space. In the bottom left corner, we have the accessibility requirements for a turning space. It's kind of laid out on one way. One thing I do want to call attention to is that we added a red outline to call out the differences between traditional sidewalk, which is 4-inch sidewalk over 4 inches of GABC, as well as 6-inch sidewalk over 6 inches of GABC. We did this to kind of make it more apparent what the section is, and also kind of reduce the section views that need to be shown in the details. In the top left corner here, we have isometric views and section views of a parallel and perpendicular curb ramp. Kind of gives the user an idea of how both applications are going to be coordinated with the elements to create a ADA acceptable application, and again reduces clutter elsewhere on the sheets. There's a note there that says to go see the appropriate sheets in the detail sheets for specific applications. In the bottom left corner, we previously talked about this accessibility chart. It has a design layout standard and also has a accessibility and acceptance standard. So again, go back to the cross-slope example we gave. The accessibility standard is 2%. So we want to lay it out to be 1.5%. That way we build in that accessibility buffer on the front end to try to give some room for variance in construction and material. And in the bottom right corner, we have a lot of notes that apply to all the sheets in the set. And then each sheet that's part of the detail set, one of the first notes is to go see the general notes on the first sheet. So sheet 2 of the updated standard construction details, these are for type 1s, and this is the type 1 is defined as a pedestrian, a perpendicular type curb ramp. So we brought back the curb ramp terminology. And for this application for sheet 2, it is dual approach perpendiculars. So if you look at the top left, the user can access from either the top of the screen or from the right that perpendicular curb ramp. So dual approaches. And the idea behind this is to give multiple layout alternatives for the designer to lay out in their plans, as well as construction to say, these are how I need to lay out the components of the curb ramp in order to make a compliant feature. Please note that we added a note to this detail to kind of call out the diagonal curb ramp requirements. Again, there's requirements that are specific to diagonals that aren't specific to the other types of curb ramps. And basically the note says a single perpendicular curb ramp located on the apex of a curb return and which serves 2 separate crosswalks is considered a diagonal curb ramp. Installation of a diagonal curb ramp, which requires the approval of the Department of Civil Rights Office. So again, built in the diagonal curb ramp idea into these details as well. Sheet 2, more type 1s. Type 1s are all perpendicular type curb ramps. And we show how you can lay out a single approach perpendicular type curb ramp. So instead of being able to access from two directions, as we showed in the last sheet, these are all only accessible from one direction. So a single approach perpendicular type curb ramp. Additionally, we included the note about a diagonal curb ramp as well. If one of these street crossings, if there's two street crossings at one of these curb ramps is considered diagonal curb ramp, requires the approval of the Office of Civil Rights. This is sheet 4 of the updated details, and sheet 4 we've now transitioned into type 2s, which are parallel type curb ramps. And again, the intent is to show multiple layout alternatives for parallel type curb ramps. So you have parallel curb ramps that are shown on a tangent, parallel curb ramps on a radius. And we have one that's a new detail in the bottom left corner where you take a parallel curb ramp and kind of wrap it around a radius. And the nice thing about this is that when the user aligns that bottom turning space, they're aligning and going over that bottom grade break perpendicular to the grade break. Again, we deal with diagonal curb ramps with another note. And in this case, we call it shared turning spaces rather than a diagonal curb ramp. Shared turning spaces are not. They require approval from the Office of Civil Rights, something we don't want to do again. Type 3 curb ramps on sheet 5 is combination type curb ramps. So again, this is where you have a parallel curb ramp usually to bridge the elevation down to a common turning space, and you have a perpendicular curb ramp that takes the user out into the pedestrian street crossing. Again, the diagonal curb ramp terminology is kept if you have two street crossings being served by that one combination ramp, it needs to be approved by the Office of Civil Rights. Now we come to the type 4. The type 4 is depressed corner. Again, new terminology for the manual as well as the details. So again, depressed corner, it is what the definition is. It's depressed corner. Depresses the corner so that the user can access the pedestrian street crossings. And we added a note in here that we talked about before for the department's preferences, is we want to consider depressed corners only after we've considered paired perpendicular and paired parallel ramps. Don't put in a depressed corner until you've considered those applications. Now we have the type 5, which is the one that everyone always gets right on their plans. Type 5 is the median application, pedestrian refuge island. Didn't do much changes to this detail. We still have the application that's a ramped application. We still have the cut through. Did some minor updates to, again, make the legend applicable and try to lay out the different areas. And something else that we did is in the bottom right corner, we put all the notes associated with detectable warning surfaces, as well as application areas all into one spot to be easy to use for reference. So now that we talked about the different type of pedestrian street level connections, we can start talking about the requirements. So the easiest way to think about this is that the department adopted the PROWAG on these items, and the reason why is it offers additional flexibility that isn't present in the ADAG requirements. And the PROWAG breaks up curb ramps into two sections and has an additional section for common requirements. And there's also a section in the PROWAG for blended transitions, and they also are included by common requirements. When you combine all those, you get the matrix that's on the slide here, of what requirements there are for all the different types of pedestrian connections. So for example, the perpendicular grade breaks are required for perpendicular curb ramps, parallel curb ramps, diagonal curb ramps, but not required for blended transitions. However, if you look at the clear space requirement, it's required for all 4 of those applications. They apply to all 4 pedestrian street level connections. First technical application we're going to talk about is turning spaces. So a turning space is any location along a pedestrian access route which provides a location for a user to change their primary direction of travel. Kind of a vague definition, but that's the vagueness that's incorporated from the federal level. They're typically located at the top of perpendicular type curb ramps. We talked about the layout of perpendicular type curb ramps before, and they're located at the bottom of the ramp for parallel type curb ramps. The idea behind the turning space is it gives the user a location where they can orient themselves and to change their direction to access either the pedestrian street crossing or to access the PAR. So because of that maneuvering that's going on there, we want to create a level area for them. So level means a 2% running slope, 2% cross slope. We'll talk more about cross slope later, but that's generally the accessibility standard. And again, the department's adopted a 1.5% design cross slope and running slope for these applications. Turning spaces themselves are required to be 4x4. There's additional requirements if you're in a constrained location, and typically the department's going to request that you do design a turning space to be 5x5 minimum, and we have that back in our standard construction details as well. A couple of slides to help you understand why turning space is required. So here we have red lines showing how the user can maneuver on the pedestrian access route. So for instance, they can come up on one of the pedestrian street crossings, turn and go up the road or continue along the road. And the user is going to need to make a turning movement at that location, depending on which direction they want to go. So perpendicular type curb ramp, turning space at the top of the curb ramp. So the issue with this application is perpendicular curb ramps. User comes up and there's no level area or turning space at the top of the curb ramps to continue along the pedestrian access route. So that would be something that would be considered an accessibility challenge for the user, as they wouldn't have that level area to be able to turn and orient themselves on the pedestrian access route. Parallel curb ramps. So again, same philosophy. Put down the red lines to show how the user can maneuver along that path. So again, red circles shows you the user being able to turn to access the street or being able to turn and go up the pedestrian access route, the sidewalk. So that's why we need the level area at the bottom of the inline parallel curb ramp. This application here, I believe it was referred to as a hot mess the other day. And the reason why is that there's no turning space at the bottom. So the user is on a curb ramp grade at 8.3%, and they're trying to maneuver themselves to get into that crossing. Very difficult maneuver for a mobility device user. Now we come to combination type curb ramps. Again, see that middle turning space that's located between the inline parallel type curb ramp and the perpendicular type curb ramp that takes you out to the pedestrian access route, the pedestrian street crossing, sorry. So a question that I will ask you, and I want you to think about for a second, is a single approach perpendicular type curb ramp, where is the turning space? The answer is there is none. The user comes down and they access the curb ramp, they don't need to turn, and then they can access the pedestrian street crossing. So the U.S. Access Board has guidance on this as well, and this is for the ADAG, but it also applies to the PROAG as well. So the image on this slide is from the Access Board, and their quote is, if the only connecting accessible route runs parallel to the ramp run, the top landing can be a slope of 1 to 20 max. So that 1 to 20 max is 5%, which in the ADAG is the running grade that's allowable for a pedestrian access route. In our environment, from a public right-of-way standpoint, is that our running grades is permitted to be equal to that of the general grade of the roadway. So it can be 5% or it can exceed it if it's in line with the roadway. So this is kind of the Access Board statement that we don't need a turning space where there's no turning maneuver. And the turning maneuver would be a change in the user's primary direction. So this practice is accounted for in the manual, especially in Chapter 4. It's also accounted for in the details. So the detail on the left went through those examples before for perpendicular type curb ramp, and you're going to have that turning maneuver at the top of the ramp based on being dual approaches. However, on the right side of the screen, we have a single approach, perpendicular curb ramp, and we have a C Note 5. Note 5 basically states that you don't need to have a turning space. There's no turning movement required. And again, this should only happen on single approach perpendicular type curb ramps. Curb ramp turning spaces, again, mentioned we adopted the PROAG for most of the pedestrian connection elements for our standard. And the PROAG requires that a 4x4 foot area be provided for a turning space. However, the PROAG also includes requirements that the turning space be elongated in the direction of the pedestrian street crossing in applications where the turning space is constrained. Constrained is not defined by the PROAG in that application. So the department had to create their own definition of a constrained area. And that's what a constraint is, and that's the reason for the advisory at the bottom. So the advisory states that any feature that projects more than 2 inches above the surface of a pedestrian access route creates a constraint. And so the idea behind that is that 2-inch dimension could affect the mobility device user and kind of hinder their turning movement. We did some research as a project team on this, and this seemed to be pretty consistent throughout the user agencies, though there was some variability on this. So this slide creates a graphical representation of the turning space and how it's aligned with the pedestrian street crossing and also the ramp. And the thing that I want to note with this is this image is for the accessibility standard, not our design standard. Again, mentioned before, we want to have a 5 foot wide sidewalk. The accessibility standard for sidewalk is 4 feet. If you apply that 5 foot design width, then usually you're going to have a 5 by 5 turning space, which is what we have in our details. So usually that constrained application shouldn't be an issue anyway. Curb ramp running slope. So I think a lot of us are familiar with the 7 or 8.3% running slope criteria for a curb ramp. However, there's a provision in the PROAG, which we adopted, and it has been adopted by the department for some time, that the curb ramp, the length of the curb ramp can be held to a 15-foot maximum, and the grade on that curb ramp can exceed that 8.3% in grade chasing scenarios. So again, our guidance is let's lay them out to 7.5% up to 15 feet. If we exceed, if we need to exceed that 15 feet for the 8.3%, just leave it at 15 feet and let the grade exceed that 8.3% maximum. And we adopted a note for the details to this effect as well. So the bottom bullet here is the note that's added to the details, is that to avoid chasing grade indefinitely on steep roadways, ramp length is not required to exceed 15 feet regardless of the resulting ramp running slope. And if you think back, this is why on a grade chasing scenario, we don't want to have a perpendicular type curb ramp, which has a steep running slope, throwing someone into traffic. Curb ramp side flares. So side flares are required for perpendicular and diagonal type ramps and can be for certain depressed corners as well, depending on the orientation of the depressed corner. The idea behind the flared side is to not create a tripping hazard. If you didn't have that flared side there, you'd have an elevation difference that if there's pedestrian cross traffic allowed, someone could step off, roll an ankle, and we want to avoid that. The side flare itself is not part of the pedestrian access route. That's stated in the PROAG as well as the ADAG. The department's preference, so we can also use return curbs or use tapered curb at a 4:1 where there's no pedestrian traffic permitted cross traffic. So if we have a landscaping area or street furniture blocking the path across the curb ramp where that elevation difference is, we can use a return curb. However, the department's preference is that we use side flares. And the reason for that is from a plowing perspective, we don't want to create that obstruction of a return curb on the side of right on the side of the road that a plow can hit. Again, 10% maximum is what the accessibility standard is. So what we've done is we've said, let's design these at 9.5%. Let's try to lay out something at 9.5% and give ourselves some room, some wiggle room on the back end. So as I mentioned, our preference is put in these side flares, but you can also put in a return curb or a 4:1 tapered curb with grading at locations where the cross travel is blocked to the pedestrian. However, again, we want to put in the flare. So we added a note that says that to the standard construction details, which says, please put in a flare unless improved otherwise by the engineer. So in that case, the contractor can say, hey, I want to put in a return curb here. The engineer can say either yes or no. So a little bit more information on side flares for diagonal ramps. So this comes from the ADAG. They have their specific technical requirements for diagonal curb ramps. This is the accessibility standard, so we have to follow it. And you can see the highlighted language here is that diagonal curb ramps with side flares shall have a segment of 2 feet curb long minimum located on each side of the ramp within the marked crossing. So that's the 2 feet shown here. That's on the outside of that side flare. And you can see from the striping that's shown on that image, that needs to be inside of the pedestrian street crossing. And the reason for that is it gives another detectable element for the person that's trying to access that curb ramp. To give an example here, this is a diagonal curb ramp, City of Dover. You can see the flares here, and you can also see where the beginning of the full height curb begins. You can see that inside, we don't have that 2-foot length of full height curb inside of that street crossing. Therefore, this would be a violation of that ADA standard. So if we're going to put in a diagonal curb ramp, we need to meet that 2-foot length requirement. And that is something that we put back into our standard construction details as well. Curb ramp grade breaks. So grade breaks is defined as where two locations that have separate slopes come together, i.e. a grade break. They need to be parallel or perpendicular to the path of travel on a ramp. And the reason for that is that it makes for easier maneuverability onto and off of that ramp. If it's skewed, it can create some challenges for the mobility device user. So ramps is a requirement, and on blended transitions, it's not required. However, it's still a best practice to have the grade breaks be perpendicular. So as I mentioned, that's an accessibility challenge for users. 2 images on this slide, both come from the FHWA. So the image on the bottom left shows a grade break that's not perpendicular to the ramp. So you have that kind of a skewed, and you can see you have a wheel coming off the ground, and it just creates accessibility challenges for users. The image on the right has the grade breaks perpendicular, and the user is easily able to maneuver up and off of the ramp pretty easily. So 2 images here drive home this point. The image on the left shows the grade breaks with the red, and those grade breaks are perpendicular to the ramp, not perpendicular to the street crossing, perpendicular to the ramp. So in that case, it'd be considered, would meet the requirements that are in the manual. The location that's on the right, however, that bottom perpendicular grade break, or the bottom grade break, is not perpendicular to the ramp. Therefore, the accessibility device user, mobility device user, may have some trouble going on and off of that ramp. So let's not do that. And again, here's an image that shows why this would be a challenge, is that the person would have to kind of either swing wide to take that grade break perpendicular, or just create some instability as they're trying to maneuver that. Pedestrian connection width. This is another fun topic. So the ProWag, we adopted portions of the ProWag for this. We adopted the ProWag portion that all curb ramps, blended transitions, and turning spaces shall be 4 foot wide minimum. However, we adopted a portion of the ProWag that's primarily related to shared use paths as guidance. And the guidance is that the turning space, the blended transition or curb ramp is to be the same width as the approach pedestrian access route. And so why that's an issue is the image that's on the bottom right here is if we adopted that as is, the ProWag language as is, that curb ramp and that turning space could be held to an ADA standard where we're making it as wide as the really wide approach access route, which would be difficult. We also adopted some language that made it clear that pinch points are not allowed on these facilities. And we also added a note to our standard construction details, which gave the department's preference of that the 4 foot is the accessibility minimum. We want to lay out for 5 feet, but 4 foot is the accessibility minimum. But on a shared use path, we want to try to give a width that's equal to the shared use path. But that in and of itself is not the accessibility standard. So the example that I'm going to give you here and kind of shows why the department went the route it did, shows a 10-foot wide shared use path coming down to a pedestrian street crossing. There's sidewalk on the far side of the street crossing, and there's sidewalk on the near side as well. So the question is that curb ramp a violation of the ADA and the spirit of the ADA? Remember, the spirit of the ADA is to remove access barriers. So if I ask the group right now if there's an access barrier here, I'd probably get some mixed responses. The ProWag would say, the current ProWag would say this is an accessibility barrier. whereas the ADAG would say this is not an accessibility barrier. So to try to create some flexibility for the department, leave some room for engineering judgment, we said that minimum, we want a 4-foot wide curb ramp and a 4-foot wide turning space. However, please provide a path that's the same width as the approach shared use path. So trying to get the best of both worlds here. Pedestrian connection cross loop. This is going to be another fun topic. So we talked about before, section 3.1.4 of the cross slope requirements for the pedestrian street crossing. And the guidance here for the curb ramps is very similar. Essentially, we want a 2% max. We want to lay it out to 1.5%. However, depending on the traffic control at the intersection, we're allowed to go up to 5% or to match that of the roadway. So if it's not stop controlled, without yield or stop control, we're allowed to go up from section 3.1.4 up to a 5% maximum. At a mid-block crossing, we're permitted to meet the general grade of the highway. However, we also are required to have flush connections between the pedestrian connection and the pedestrian street crossing. So that requirement to have a flush connection also brings project type into this consideration as well as the traffic control present. So take a step back and think about the project types that we talked about before, where reconstruction was not a project type. So new construction is required to meet the accessibility standards. So in that case, you want a 2% accessibility standard. Alteration type projects are not required to change the pedestrian street crossing cross slope, where the work would be outside of the feasible scope of the work. And then maintenance type projects don't need to correct any ADA compliance items. So from that, we get that traffic control dictates the allowable cross slope, and we also get that the project type from chapter 2 is going to dictate the cross slope requirements. And real quick, the bottom note here, the bottom bullet, we adopted in the standard construction details, we added a note which essentially reflects this practice, is that the element that abuts the street crossing is going to have to match that of the pedestrian street crossing. So rather than holding somebody to that 2% when it's not, they can't do it, we put in that note accordingly. So try to give a little bit more information on this, try to really get into the weeds on this. This is a curb ramp, a perpendicular curb ramp, and you can see the pedestrian street crossing. The element that's going to meet the street crossing is that yellow shaded area, which is the ramp. That cross slope of the ramp, in order to make a flush connection, is going to have to match that of the street crossing. This is a perpendicular type curb ramp. The element of the curb ramp that abuts the street crossing is the turning space. So in order to create that flush connection, the turning space, the cross slope of that turning space is going to have to meet the pedestrian street crossing. And the thing that's nice about this is that a parallel curb ramp, the running slope that's required, so pointing into the street, is a 1.5% from a design standpoint. That matches the cross slope of the approach pedestrian access route. So really the only element that needs to be transitioned is that turning space. So now we get into depressed corners and blended transitions, which is highlighted on this screen. So the blended transition, the ramp segment at the bottom, is going to have to match whatever that street is in order to have a level connection or a flush connection. So I mentioned before that the parallel curb ramps are not going to have this issue of the transition because all going to be contained to that turning space. However, perpendicular curb ramps, to meet the maximum extent feasible language of the CFR, is going to be required to provide a turning space or a connecting pedestrian access route that is compliant to the maximum extent feasible. So that what that means on this top image, if we have a paired perpendicular ramp, that turning space at the top of the ramp segment needs to be built to the ADA standard, which is 2% maximum cross slope, running slope, 1.5% is what we want for design. So if the bottom of that ramp is held to the street crossing cross slope, that means that all the transition is going to need to occur inside of that ramp segment. So the department adopted some guidance on this, and please note, this is not an ADA requirement. If you look through our standards, there's no requirement for how you transition that cross slope and the rate you transition that cross slope. However, we wanted to remove some subjectivity from this, and we wanted to give a criteria. So the criteria we adopted was a 3% cross slope transition rate over a per foot basis. So again, have a 5 foot ramp, multiply that by 3%, you get 15%, you can transition that cross slope. Is that a best practice? No, we ideally want that to be flatter, but we really shouldn't have that occur very often in Delaware. And the 3% was a value that we evaluated from other states, what other DOTs are doing, and 3% is pretty common. Again, we don't want to hit that, but others are doing it, so that's what we kind of decided to follow. Try to remove some subjectivity from the practice. And real quick too is to remove, because of how the DWS, they're rigid, they're not going to be able to bend with that transition. So begin the transition at the back of the DWS from a constructability standpoint. So now a couple more examples on graphical representation of how to apply the cross slope requirements. So again, perpendicular curb ramps are the big one. You can see we have the turning space in blue. So that turning space in blue is made to be compliant with the 1.5% design slope in each location. And then over the ramp segment, we're transitioning that cross slope so that we're hitting the pedestrian connection, the cross slope of the street crossing. So for example, on the right side of the screen, we have a 5% pointed away from the intersection, and the turning space is 1.5% in the other direction. So that's a 6.5% cross slope difference. You apply that 3% rule, and you require a little bit more than 2 feet of ramp to transition that cross slope. Again, that's not a great transition rate, could create some mobility device challenges, but that's not an ADA requirement of the ADA. That's one of those locations that best practice, we can achieve better, let's do it, but not an ADA requirement. So pedestrian connection counterslope. So this is another place that the department's slightly modifying our standards. And the counterslope is the angle point or grade change where the downslope of the street level pedestrian connection meets the upslope of the adjacent gutter or street. The department has decided to adopt the PROWAG standard, which is the same as the ADAG standard. And this applies to all pedestrian connections. So blended transitions, curb ramps, or depressed corners as we're calling them, all have the same counterslope requirement. And the counterslope requirement is the counterslope of the gutter or street at the foot of the curb ramp runs. Blended transitions and turning spaces should be 5%. So the 13.3% maximum algebraic difference that the department's using now is not going to be the standard moving forward. The 13.3% counterslope criteria was actually something that was discussed in the PROWAC, which was a report that helped generate the PROWAG, but it was not carried forward from the PROWAC into the PROWAG and is not the accessibility standard that's highlighted in the ADAG. Therefore, that is the accessibility principle behind the 5%, but it's not the actual standard. And the accessibility principle behind it is if you take 5, which would be the counterslope of the gutter pan, and add that to a pedestrian connection, a perpendicular curb ramp, it's 8.3 plus 5, 13.3%. However, the PROWAC actually recommended adopting an 11% algebraic difference. So even that 13.3% was slightly out of compliance with the 11% recommended by the PROWAC. But again, the standard is 5%. Department has adopted a 4.5% layout standard to again try to reduce these compliance issues in the future. And real quick to emphasize, the accessibility, the usability and accessibility idea behind that counterslope criteria is the algebraic difference, though it is not the standard. So if you have a place that violates the 5%, you can use some logic behind it to try to justify your location. So one of the things that the PROWAC also recommended was if you violate that counterslope criteria of what they suggested was 11%, was to add in a level strip, a 2-foot level strip between the two different slopes. So we have the slope of the ramp, and we have the roadway slope or the gutter pan slope. And they took a 2-foot area, put it between the two. And the idea behind that is to not create that snagging point. So in the top image, you see the wheelchair user coming down, footrest gets caught, and this becomes an accessibility challenge. Whereas in the bottom, you add that 2-foot level strip, and the wheelchair users can more easily traverse over that location. So again, this is a mitigating technique that can be used where you're not able to meet that 5%, or you have other features there that are violating the actual accessibility principle behind it of the counter slope criteria of the maximum algebraic difference. Now we get into pedestrian connection clear space. So clear space is in both the PROWAG and the ADAG, and it's kind of a difficult concept. So we're going to back all the way up to where the clear space originally came from. Clear space originally comes from the ADAG, and for the ADAG, it came out of 406.6, which is just for diagonal curb ramps. And the ADAG states for diagonal curb ramps, the bottom of diagonal curb ramps shall have a clear space 48 inches minimum outside active traffic lanes for the roadway. All that's given from the standard standpoint is clear space. There's no technical requirements on the grade or the cross slope of that clear space. You can see on the image where that clear space aligns. You have that 4-foot area that needs to be outside the active travel lanes. Again, just a clear space, no technical requirements. So the PROWAG went a step further, and the PROWAG said that clear spaces are required for all blended transitions and for curb ramps. And again, the PROWAG required that the clear space be 4x4 in this, for these locations, and it'd be outside of, their term was parallel vehicle travel lane, and wholly outside the parallel vehicle travel lane. So again, the PROWAG also does not offer any technical requirements for that clear space. So the clear space is a clear space. There's no grade requirements, there's no cross slope requirements, it's just a clear space. So if you're like me and you hear parallel vehicle travel lane, you ask yourself, what does that mean? So we asked for clarification on what a parallel vehicle traffic lane means. We got that clarification, and the clarification we got is on the screen, and if the lane is marked, the travel lane would be measured from the outside of the striping. If the lane is not marked, to be measured from the tangent to the face of the curb prior to the radius. If there is a turn lane or auxiliary lane, it would be considered a travel lane. So that definition is a little bit problematic, and the reason why it's problematic, we have highlighted on the screen. It's an aerial view, a very, very typical application in Delaware. We have a pork chop island, and we have a access route going through that pork chop island. The little red areas are meant to show the clear space. If those are the clear spaces, that 4x4 space, that's in what is considered the parallel travel lane, which would be a violation of the ADA. Another image, this is the street view image of the previously shown aerial image. And again, very common application in Delaware, and that 4x4 clear space would be in the parallel vehicle travel lane. So this would be a violation of the ADA, according to the PROWAG. Another very, very common application, you have a crosswalk, and the clear space at the bottom of the curb ramp would be in the parallel vehicle travel lane based on the definitions that were provided. So again, this application would be a violation of the ADA. Based on that, we asked some questions to the U.S. Access Board, trying to see what is the reasoning behind the clear space? Why do we need that clear space where we do? So we asked some poignant questions, and we got some responses, and this slide highlights the responses. So one of the questions that we asked is, what is the intent of the clear space? The response that we received is the clear space provides an area for mobility device users to adjust and line up with the crosswalk. For pedestrian safety, the clear space needs to be located outside the parallel vehicle travel lane. So one thing really nice about that statement is it clarifies it's an area for adjustment, for maneuvering. It's not a turning space, it's for maneuvering. We asked, is the intention of the clear space to be turning space? And the answer we got is a clear space doesn't serve the same function as a turning space. Again, no technical requirements for the grades or the cross slopes for the clear space. It just needs to be a clear space. And finally, is the intention of a clear space to be a waiting area, and it's not designated as a waiting area either. We also gave the Access Board several examples of where the clear space would fall to make sure we are applying the concept right. They confirmed it, the concepts that or the locations we showed, and they pointed to one application in particular, and that's shown on the slide here, which shows the gray highlighted clear space with the grade breaks at the bottom and top of the curb ramp. And the statement that we got is that for the image below, the clear space is not critical because the curb ramp is perfectly lined up with the crosswalk. Based on all that information, the department had several internal discussions, several options floated, and we decided that we're going to stick with the ADAG language as the standard. It is the accessibility standards that is what we're required to do. Therefore, all diagonal curb ramps are required to have that clear space outside of the active travel lanes. The ProWag is best guidance at this point. We thought that the geometric changes in the right-of-way that would need to be acquired in order to provide that clear space to meet the ProWag standards wasn't feasible for the department. So we adopted the ProWag language as a guidance at this point. Therefore, if you can, locate the clear space outside of the parallel vehicle traffic lane. However, if you don't, it's not a violation of the ADA. It's a violation of what we consider the best practice. And additionally, we added some advisory language that kind of summarizes some of the information that we received from the Access Board of the purpose of the clear space. Working through this update with folks from around DelDOT and working nationally on this too is that the clear space is a very ambiguous area. So we wanted to provide as much information on that as we could. The slide shows you how we dealt with the clear space issue inside of our details. So this is note 12 on the general note sheet. And basically the note is saying that if we have a diagonal curb ramp, you need to provide that 4x4 clear space outside of the active travel lane. However, we do want that clear space for all our applications to be inside of the pedestrian street crossing as well. And that's a best practice. And the other thing that we did highlight real quick is we have a curb ramp on the far right here on the slide. And that shows you where the clear space is aligned with the curb ramp as well. Try to take some of the ambiguity out of where that clear space falls as well. Another topic that we've talked about a lot as a department was our requirements for pedestrian connection drainage. So just the way that pedestrian connections are laid out creates the potential for water accumulation. So one, you're taking an elevated access route and you're lowering it to the street level connection or to the street connection. And you're also channelizing water typically at the curb line. So in addition to that, we're also going to flatten the gutter pan slope based on our accessibility requirement for the counter slope. So all those criteria kind of create the potential to pond water right at the bottom of the ramp. And ponding water also has the issue of hindering operations both during and immediately after a storm event. So the ADAG currently includes a section called wet conditions for section 405.10. And it applies to curb ramps as well. And the language essentially boils down to curb ramps and blended transitions shall be designed to prevent the accumulation of water. So pretty vague statement, designed and to prevent accumulation of water. No technical requirements of what accumulation of water means. So because it's part of the ADAG, we incorporated it as a standard. However, it's fairly vague in what that means. We offer also guidance. Let's try to consider this during the design phase. During the design phase, you have more opportunities to assess the conditions and either try to mitigate the conditions or to fully investigate it. And again, this also plays a part in the accumulation of sediment, something else that we talked about quite a bit in the update to the manual. So we did, chapter 3 has a standard we showed on the previous page, designed to prevent the accumulation of water, but we also added some additional design information to chapter 4, design considerations on this topic as well. Again, provided more flexibility in design considerations to tell the user, here's some other things you should be aware of. So the language that we adopted there comes from the AASHTO Green Book, section 4.17.3, which essentially says, where you can, please put an inlet, a drainage inlet on the upstream end of curb ramps and crosswalks. Try to take away some of the water before it gets to the curb ramp where it can pond. In addition to that, the department also adopted a 1% minimum running slope and cross slope. This is a department guidance. It's not an accessibility standard in of itself, but the idea is try to create some positive drainage mechanism, and we understand that that might be difficult in some areas of the state. The other thing that we added to that chapter 4 was try to create and establish a consistent flow line, so you don't have local sumps inside of the curb run. That's just going to accumulate water. Again, a best practice, not an accessibility standard. So here's an actual application during the rain, and this kind of shows you some of the considerations that should be taken into account during the design phase, and also try to relate back to our standards. So we have a drainage inlet placed here, not at the low spot and away from the pedestrian connection. So you're never going to have positive drainage from that pedestrian connection to that drainage inlet. What most likely happened during construction is that you added a shoulder, put in a sidewalk. The trunk line most likely for that pipe network was right where that inlet is. So during design, what they could have done, if it was inside of the scope of the project, was move that inlet closer to the low spot, drain that pedestrian connection, and try to prevent the accumulation of water, designed to prevent the positive accumulation of water. Pedestrian connection directionality. So I hinted on this a couple times before today, and I'm going to walk through the concept of directionality. So pedestrian connections can be put in line, the ramp segment can be put in line with the pedestrian street crossing to make what is called a directional curb ramp. So the images on the left are curb ramps that are considered directional. The images on the right are non-directional. They're not in the direct line with the pedestrian street crossing. This is not an ADA standard. This is a design consideration. Both the image that's on the slide comes from the ProWag. So both are considered acceptable. And in order to make it directional, we have to create a little funky triangle, which I highlighted on the screen on the bottom of the curb ramp on the left. So again, the Title 28 of the CFR, the ADAG and the ProWag don't mention directionality, let alone give any standards for directionality. There is some discussion in the ProWag, which was the advisory report that was generated ahead of the creation of the ProWag, which has a discussion on directionality. And that discussion is that a quote, it's not a standard, and not something that was suggested as a standard, but just a statement, was that the curb ramp should generally align with the expected path of travel to provide directionality. So in other words, try to create something directional to give the user some cues. The ProAct also states that it helps blind and visually impaired individuals align with the crosswalk. And they also recognize the challenges that creating this directional curb ramp can create. The ProAct contains the following quote: "The skew may cause a wheelchair to become unbalanced. The cross slope of the ramp, the gutter grade, the street crown grade, and the skew angle of the ramp all combine to cause one or two of the wheels of a wheelchair to lift off the ground surface." So one, they're recognizing the advantages and also the disadvantages. So there's good and bad with this, and it's really related to the user. So we added to the manual to give the department's preference is that what we would like is, from a standpoint of just directionality, is that we would like them to be aligned. That's the preferred directionality. Obviously, something aligned is better than something not aligned. However, there's a lot of different considerations that go with that. The middle image is acceptable, not preferred, but acceptable. And the image on the right is undesirable. It's not a violation of the standard, just undesirable. The image on the right is a diagonal curb ramp. If you meet the technical requirements of a diagonal curb ramp, it is acceptable for an alteration type project. A couple of examples, thoughts of directionality on this. So again, before showed you a couple images of a perpendicular curb ramp that's not directional. This again is a perpendicular curb ramp that's non-directional. It's not ideal, but from a directionality standpoint, but perfectly acceptable. And again, this was the example too of the grade breaks I showed before. Another example, we have two here. So the image at the top, it's pretty directional. It's fairly in line with the direction of the street crossing. The image at the bottom is not directional at all. If the pedestrian's coming from the pedestrian connection and entering the street crossing, they have to make a 120-degree turn or so to continue along the street crossing. So not ideal, however, it's not a violation of the ADA. Another directionality example. So the image on the, the middle crossing is directional. The crossing is pretty much perpendicular. The curb ramp is laid out so that it's perpendicular in line with the crossing. The image that goes, or the crosswalk that goes across North Street is not directional. The curb ramps are not aligned at all to align the user to the crossing. Again, both are compliant. One is better, one is not good from a directionality standpoint, but not a violation of the ADA. Example here, two pedestrian connections and how they're coordinated with the marking. So not good from a directionality standpoint, but also a violation of the ADA. And the reason why is that the pedestrian connection is not wholly within the pedestrian street crossing. The other thing to consider with this is the curb ramp grade breaks and how to consider that in connection with the directionality of the curb ramp. So as we said before, on curb ramps, where the ramp segment, we want the grade break to be perpendicular to the user's travel. And the reason why is to create stability for the user. So when you combine the principles of directionality as well as with grade breaks, you arrive at two options. Option one is to place the grade break at the bottom of the curb ramp that's at a 90-degree angle to the curb. So this is good from a drainage standpoint. You have the 8.3% sloped ramp segment at the bottom, reduces that skew that can cause challenges for the mobility device user. But from a alignment standpoint, it's not in line with the pedestrian street crossing. The option number two is to create that funky triangle. The grade break is still kept perpendicular to the curb ramp. However, you're creating that skew, which may cause some issues for the mobility device user. And also, because you have that flat area at the bottom, you might have a location that can accumulate water. So if we do install that funky triangle, the accessibility standard for that is 5%. We would treat it as a blended transition, or we would treat it as part of the grade requirements for the pedestrian access route. But ideally, we want to leave that at 2%. So again, going back to what's in the manual about directionality, please note that how the grade breaks are aligned with the pedestrian connection and the ramp, so that you can to create stability for the user and also create directional alignments. And again, this is contained in Chapter 4. This is design considerations. We give you the considerations. It's not an accessibility requirement. It's for the engineer or the person laying it out to make these decisions on a per basis cases. So pedestrian connections through median applications. The user is really given two options. You can either create a cut-through application, which is shown on the left side of the screen, or you can create a ramped application, which is shown on the right. Both are acceptable from an ADA perspective, and there's two things you need to consider when prescribing the application of either one. So from a drainage standpoint, the ramped application's preferable. The cut-through application can pass water through if not designed correctly, but also you need to consider the vertical alignment. It's not necessary to create small hills or create elevation changes where you don't need to create elevation changes. So the figure on the left side of this slide is 406.7 of the ADAG, and it shows a 4-foot area at the top of the ramp segments. So this is an ADA requirement. And the idea behind that 4-foot segment is that you're spreading out the algebraic difference from the two ramp segments. If you had the two ramp segments come together and abut each other, you could have a 8.3 plus an 8.3, 16.6% cross or algebraic difference at that location. Therefore, we want to have that 4-foot area in there from an ADA perspective and also from a best use perspective as well. The image on the right side of the screen is our standard construction detail. So again, we show both a ramped application and a cut-through application. And we have a note on there as well that kind of lays out the department's preference. Basically, the department's preference is please give us a cut-through application as is the preferred treatment. One thing real quick about what's in the ProWag is the ProWag also has a statement that states that the edges through the cut-through pedestrian refuge island can provide a useful cues to the direction of the crossing. So that's another reason we like the cut-through application, because it helps align the user and tell them where to go on that application. If we didn't have that, the user would get on top of that channelizing island and wouldn't have many directionality cues to navigate that median. So a ramped application in Delaware, hard to find, but I did find one, and I took a picture of it. So on the far side in the middle picture, you can see there the ramp at the bottom. It takes the user up to the level of the median island, and then the user has no directionality cues once they get on top of that island. So again, not preferred by the department, but is acceptable. Then on the right side is an image that we got from the U.S. Access Board, and it shows that, especially that 4-foot area, why it's required. So that image would not be very friendly to the mobility device user. And this is the note that we added to the standard construction details that made the requirement of, or makes the requirement clear of that 4-foot area at the top of ramped applications that were required to have a turning space in those locations. So detectable warnings, truncated domes. So important that this conversation, we're going to focus on truncated domes. There are other types of detectable warning surfaces out there, but this conversation is specifically about truncated dome or truncated domes. So truncated domes have a specific meaning in the public right-of-way, and they're meant to indicate the boundary between pedestrian and vehicular routes where there's a flush rather than a curb connection. So I think we all recognize that if there was a curb at the bottom of the pedestrian street crossing, that a mobility device user can't go over that curb. So therefore, it's a barrier. However, that curb was a useful detectability cue for the visually impaired. So when we remove the curb, we have to put something back as a cue to the visually impaired to alert them to that street crossing. So if you think about it, the truncated dome detectable warnings are kind of a accessibility compromise between those two user groups. As I mentioned, there are other types of detectable warning surfaces in the public right-of-way. Most notably, DGM 128. We have directional tactile surface indicators that are used for bicycle ramps. And also other states are using some detectable warnings as kind of wayfinding devices. And the department also added section 410 to the manual as well, which discusses some of the wayfinding criteria and devices that are out there for use. A good example of DWS and the purpose of DWS and kind of removing that curbed connection, removing a barrier for the mobility device user. So the image that's on the left of the slide is an image from Street View. I went to go take a picture in person. Unfortunately, or fortunately, it had been removed before I could take the picture. And the image that's on the bottom right corner, that's what it's been replaced with. So it's a good example of there was a curb barrier there before. Remove that curb barrier, and then to alert the visually impaired to the vehicle cross traffic, added truncated detectable warnings, so that way they can know that they're about to enter into a vehicular an area that's for vehicles. So we adopted the ProWag language for locations to apply truncated domes. And so the nice thing about the ProWag is that they included all the language about DWS where they're required into one section. So it's very transparent, very easy to find. The ADAG essentially had the same requirements, but are spread out in multiple locations, and they're essentially equivalent. So the location that truncated dome detectable warnings are required are curb ramps and blended transitions at street crossings, pretty apparent. We're going to have a conflict between the pedestrian and the vehicle. And we're also going to use them at pedestrian refuge islands. Again, pedestrian refuge island is going into a pedestrian street crossing. Use them at grade rail crossings that are not at grade rail crossings as well. Again, conflict between a vehicle and a pedestrian. And we're going to also use them at boarding platforms, at transit stops for buses and rail vehicles where the edges of the boarding platforms are not protected by screens or guards. The department considers the curb that's at the bottom of our bus pad to be a shield, a screen, or a guard. So therefore, we're currently not showing DWS at those locations. And then finally, DWS at boarding and alighting areas, at sidewalk or street level transit stops for rail vehicles where the side of the boarding and alighting areas facing the rail vehicle is not protected by screen or guard. Shouldn't occur very often for the department. So as I mentioned, the DWS, the truncated domes, provide a very clear message to the user and provides them critical information. Based on that, we don't want to overuse DWS. So the information that we have as the guidance here is basically saying don't overuse DWS. We give some of the PROAG language for that as well. In Chapter 4, we elaborate on this principle more from what's in Chapter 3 and give some specific locations of where to use them and where not to. Basically, don't use them across residential driveways, comes from the PROAG, and when they can be used in engineering judgment at the following locations. This locations actually comes from the current road design manual, so we applied that here and gave some flexibility for engineering judgment to take place. One thing I hit on before for the treatment of pedestrian street crossings and cross slopes is large traffic generating facilities that are going to be designed as a pedestrian street crossing. And so those areas, the large traffic generating areas that have return curbs, please add the detectable warning surfaces there, since that's going to act as a pedestrian street crossing. And again, the example here, we have the Target in Dover, right across the street here. And so in this location, you should have DWS. It acts as a pedestrian street crossing where there's high volume of vehicles coming across. So to give the user information about that crossing, we should have DWS. Location here in Milford, you have truncated domes over a sidewalk with very, very low usage. So this is kind of one of those areas where you're diluting the message of your DWS by putting them in a location like this, at a low volume entrance. This image just shows DWS peeling up. Not sure what they put down, but that is not what we want to be using for our projects. So pedestrian connection DWS placement. So the PROAG is very explicit in where they say to place DWS. And the reason they're explicit is those locations have been selected to present a clear message to the user. So for example, if we have a perpendicular street crossing and the DWS are placed too far off of that crossing, the user gets to that DWS, they feel it, and they don't feel any change in the surface after that, and it dilutes the message and confuses the user. Therefore, it's important to put the DWS in the location that makes sense for the user and give them the most information they can. So go through real quick where the DWS are supposed to be installed for the various types. Again, our current details now are going to be based on the federal standards, which are perpendicular, parallel, and depressed corners and diagonals. So for a depressed corner, you're placing at the back of the curb along the entire length of the depressed curb. And that's what's shown in this detail on the slide, and also shown on sheet 7 of the details as well. Parallel curb ramps, again, placed along the back of the curb along the entire depressed area. Pretty straightforward for both those applications. Perpendicular type curb ramps are a little bit more difficult, and DWS placement falls into 3 categories essentially. The easiest category is where the grade break of the bottom grade break of the curb ramp is perpendicular to the curb. The DWS gets placed at the back of the curb. So that's what's shown on the right side of the screen here. Where the grade break, the bottom grade break is not perpendicular to curb, it gets a little bit more complicated. And in those locations, the key criteria is the distance between the grade break and the back of curb. Where you're less than 5 feet, the DWS should be placed in line with the ramp and the grade break. So that'd be the middle application. There is a little tiny, probably 1 foot area between the DWS, the front of the DWS, and the back of the curb. So in that case, DWS is placed in line with the grade break. On the application on the left, we have that funky triangle, and there's the distance between the back of curb and the bottom grade break is over 5 feet. In those locations, we need to put the DWS at the front, the back of the curb. And again, the reason we do this is to provide clear information to the user. Mentioned before, The pedestrian refuge islands and median applications also require DWS. Again, the user is about to cross into the street. We need to alert them to crossing into the street. The PROAG contains language that if it's the pedestrians travel through the path is 6 feet or less, or if the separation between the DWS is less than 2 feet, that we shouldn't provide DWS at that location. And the reason why is that it would dilute the meaning and confuse the user because they're going to be back to back and not as clear. So the department additionally has adopted an 8-inch offset that's in our standard construction details now, where if we don't have curb at the location, that we're offsetting the DWS from the interface of the pavement by 8 inches. So that also needs to be considered when we're looking at this 6-foot, 2-foot rule. So accordingly, if the distance between them needs to consider that 8 inches, and it's the 2-foot criteria is the standard we should be looking at. This is the note that we added to the standard construction details for this practice. Basically, you can omit the DWS or omit the DWS, and we also have the 8-inch criteria in the notes as well. Try to make the details as user-friendly as possible. We put all the information about DWS, truncated domes, in one location. That's on sheet 7. So it essentially says the details say everything I just talked about and states where the DWS should be coordinated with the different pedestrian connection types. It should be very clear for the designer that's laying it out, as well as for the field staff that are constructing it, where the DWS should be placed. One thing that's a little bit different and change of practice for the department is DWS are permitted to be on the curb ramp run. Currently, we've kind of been doing that where they don't put off the ramp run, but they are permitted to be on the ramp run. So we're also going to talk about temporary access routes during the construction phase. And again, talked about this before, have the same requirements. They have requirements under the ADA to provide access routes during construction as well. So really, there's 3 objectives during temporary conditions. And you want to separate pedestrians from conflicts from worksite vehicles, equipment, and operations. You want to separate pedestrians from conflicts with mainline traffic moving through or around the worksite. We also want to provide pedestrians with a safe, accessible, and convenient travel path. And we want to duplicate as much as possible to the existing route. So order of preference, least intrusive to the most intrusive kind of progression here. So our first priority should be to utilize existing facilities as much as possible. That's the easiest thing to do, and you can use pedestrian flaggers for this means as well. The next priority should be to maintain a portion of the existing site on the same side of travel as that is being worked on. And the reason why is you can provide same site access to the land uses that people are trying to get to. So you can do this through one of 2 ways. You can channelize a portion of the existing pedestrian access routes. So if you have space, you can put up pedestrian channelizing barriers, or you can install a new temporary path. If you don't have that availability, you can also give consideration to using a parallel or adjacent travel or adjacent parking lane or shoulder and rerouting the pedestrian into that parking lane or shoulder, or even to a adjacent travel lane if there's a multi-lane facility, which we'll talk about in a little bit. If that's not available, what we can also do is provide a pedestrian detour. This is not as preferable as the other options. The pedestrian detour is going to require additional street crossings, which creates exposure for the pedestrian. And also, you might not be able to provide access to the same sites that you would if you maintained same side access. And finally, if none of those alternatives are available, you can provide a temporary shuttle service or other method to maintain usability. So this slide shows typical application 28 from the Delaware METCD. And this is the alternative where you're taking, in this case, a parking lane and providing it for the pedestrian to access, provide same side access to the land uses. Again, can be considered on multi-lane streets as well. but you need to give consideration to the type of traffic that's there, as well as positive protection for the pedestrian. Another alternative, this is TA29, provided pedestrian detour route. This is TA29 in the Delaware MTCD. We provide a pedestrian detour route. It needs to be approved by traffic safety. In all cases, according to the MTCD, the temporary route needs to provide similar accessibility and detectability features as that of the original route, and that's an MTCD requirement. We want to adequately sign these locations so that the user is alerted to how to maneuver around these. We don't want them to go all the way to the work and then have to backtrack that same distance. So try to provide the signs in a logical manner. And again, use the MTCD as a reference for this. Want to create a compliant ADA work zone, and that's sometimes just means thinking about some items during the design phase as well as the construction phase and how it affects the access route. So in this case, we have a VMS board placed in the pedestrian access route, alerting the user to construction prior or upcoming construction about 10 days. So in this case, the design group could have thought, where is a place where there's not going to be a building that I can place this VMS board and it'll still convey the message I need to convey. And from a construction standpoint, they could have looked for another area, or they could have rotated the trailer and the sign so that it still provides the information that needs to be provided, but is outside of the pedestrian access route. On-street parking. So this is one of the more complex subjects of the public right-of-way environment. So one of the things that makes it very complex is the layers of authority that are involved. So typically, the municipality administers their parking program. If they have a parking program, they need to make it equitable. The department, however, if we affect the on-street parking with a project, so if we're doing a pave and rehab and we affect the on-street parking, we've triggered an ADA requirement. So we need to work with the municipality to figure out the obligations and what we want to do with that on-street parking. The thing to consider with this too is it goes back to project scope. So new construction, you need to meet the requirements for on-street parking. Alterations, meet it to the maximum extent feasible. And maintenance, don't need to consider the on-street parking requirements. Again, something to think about during the design phase early. Talk about it with the Title II coordinator, coordinate with them early, and try to get all of the information that you can documented about obligations and agreements for the on-street parking into the town agreement. Again, the parking is going to be the municipality's program, but we're affecting it. So it kind of creates that multiple layers of authority and creates challenges for the department. Moving out of the standards now. So real quick, didn't think these items required too much discussion today, but I did want to alert everyone to some changes, as well as from the current manual to the previous. So surface requirements, section 3.1.5 of the new manual. These are the firm, stable, slip resistance requirements that we're all familiar with. One thing that we did in the updated manual is we provided some additional clarification from the department standpoint on sedimentation and its requirements. So we used the CFR language to kind of provide a greater perspective of what sedimentation entails and requires. And we also kind of added some more information for the user to consider. The department had previously, for a vertical alignment, had previously adopted the PROWAG language. The PROWAG language has now been adopted as a guidance. So the PROWAG language for vertical alignment was the generally planar and generally smooth. We thought that was really hard and a subjective criteria to enforce. So we made that a guidance instead. What we did do instead is adopted something that's quantifiable, that's provided by the FHWA in their best practices manual from a long time ago of 11%. So if you have an algebraic difference in the pedestrian access route of 11%, please avoid that. Again, adopted it as a guidance. It's not a standard, but it's something that we want to avoid. And the good thing is it's quantifiable, so we can talk about numbers rather than generally planar and smooth. Vertical surface discontinuities. minor changes, but essentially adopted the PROAG for this. Horizontal openings, fairly similar to the existing manual, minor change on that. And we adopted the original language from the PROAG, and the PROAG focuses on the passage of a 1/2-inch diameter sphere. Flangeway gap should be similar to the existing manual. Protruding objects, slightly different criteria for standards for this as well. Real quick recap of protruding objects is there's 3 ranges to consider. You have the ground to a 2'3" high area, which is considered the cane detectable region. Then you have the 2'3" to 6'8" area, and that's the area where protrusion limits are not cane detectable, and you're permitted to have a 4" protrusion into the pedestrian circulation path, and that's pedestrian circulation path, not the PAR. Where we differ in our criteria for that area is that we've adopted for post-mounted objects, which mailboxes, traffic signs, other things that are mounted on posts, we have adopted the ADAG language, which allows for a 12" protrusion into that range. We adopted the PROAG as guidance, so we want to limit it to 4 inches as much as possible, but that's not the accessibility standard from the ADAG. And finally, the last range is above 6'8". That's outside of the vertical clearance, and need to keep that area open from 2'3" to 6'8", but above 6'8", no requirement. Transit shelters and transit stops, as well as passenger loading zones, are all consistent with the current pass manual. And one thing that we did in the updated manual, which I think played out really well, was we made a new section called Facilities Not Common in the Public Right-of-Way, where we adopted criteria by reference directly to the PROAG or ADAG. So if the department felt that we didn't need to add any more advisory language or our own guidance language, we just gave direction to go right to the ADAG or the PROAG standard and incorporate it as our own. So if you're watching, I would suggest taking a snipping of this slide. This slide summarizes the changes that we made to the standard construction details as part of this update task. The big changes was the accessibility buffer, which we mentioned before. So that required changing across multiple pedestrian facilities that are scattered throughout our standard construction details. Also updated for the width of the sidewalk, and also the pedestrian push buttons to give more flexibility to the department. But additionally, we cleaned up some of the note language to be better in line with the requirements of the pass manual, which are now aligned with the federal standards. So again, if you can, take a snipping of that screen, give yourself a heads up of what changed. We say what changed on each sheet, and we say all the sheets that have been changed. Hopefully you got your snipping. So another thing that we evaluated with this update was the current engineering instruction PM 18001, which dictates how much information should be put into the construction plans for pedestrian connections. So the EI was originally written in 2018, and what we decided to do was get together as a group of people around the department, both design, construction, and say what's been working and what's not been working. Overall, the structure of the existing EI was kept fairly intact, but what we did do is we added a section about survey considerations. This section was added based on some issues that we found in the field, and where we thought that if there was better guidance about survey requirements on the front end for pedestrian connections, we could have made the process a lot more smooth. So basically, the requirements for survey are as follows. If it's a project in the scope, it requires a full topographic survey. You need to provide full topographic survey. If it's a linear project where only the pedestrian connections require a topographic survey, you need to set geodetic control, and you need to run a traverse and bench loop that encompasses the entire project site. And the reason for that is we're going to have accurate survey at those locations that we want. If performing that geodetic control and traverse and bench loop is infeasible, then you should discuss with the project manager, and the project manager and the engineer of record can come to the decision to use assumed coordinates at that point. If you use assumed coordinates, they need to be get written approval from the department. It needs to be clearly stated in the plans and easily recreatable as well. And the other note about assumed coordinates is that if you're using assumed coordinates and it's determined that you need to acquire right away, you cannot acquire right-of-way off assumed coordinates. Delaware code requires that right-of-way be acquired off of NAD 8391. So at that point, you need to stop and get a survey anyway. So the information that's required to be displayed in the contract documents is directly tied to how constrained the environment is. The more constraints, the more information. One, to make sure, more information that the designer needs to look at themselves, but also provide that information to the contractor so they have enough information to provide or create the design as intended by the engineer. So because of that kind of logic, we created three different, and this is in the existing EI as well, three different classifications. We have unconstrained pedestrian connections, right-of-way constrained pedestrian connections, and existing feature constrained pedestrian connections. And so this shows you on the DRC how to find this engineering instruction, which has been updated at this time. So unconstrained pedestrian connections occur where the existing environment can be readily altered. So if it's readily altered, you can make a standard construction detail work pretty easily. So what's required in this location, just from a pedestrian connection standpoint, specify the appropriate standard construction detail. Then you need to provide geometric points at the limits of the depressed curb at the interface of the pavement and the curb and gutter or curb. And we also need to shade the region of the template to provide information to the contractor. And again, the engineer of record in these locations needs to verify that a standard construction detail will work. If they get out into the field and it doesn't work, then you're going to have issues there. So try to verify that during design. And again, one thing to note, based on the program developing these plans, that these can either be contained in one sheet or can be contained across multiple sheets throughout the plan set. Next, we come to right-of-way constrained pedestrian connections. So these are pedestrian connections where the limiting factor is either the existing or proposed right-of-way, and it's going to be constrained accordingly. The first priority should be to use a standard construction detail and to use that as the simplest thing to do. If we're using a standard construction detail, we want to create a detail that shows all the elements laid out, proves that it essentially fits inside of the public right-of-way footprint, and provides the same information as the unconstrained pedestrian connection detail. So in those cases, again, geometric points, depressed curb, shade the limit, and also you're going to have that construction detail which shows the right-of-way or the pedestrian connection fitting inside of the right-of-way. If you cannot use a standard construction detail, then it's still going to be within the scope of the work. You should give consideration to a purchasing right-of-way. And if that is not feasible and you still want to put in a pedestrian connection as one can fit and be considered compliant, you need to move to the next level of pedestrian connection constraints, which is an existing feature constrained environment. So this is where this type of construction occurs, where the existing environment's very constrained and you need to provide quite a bit of detail to the contractor to be able to lay out a facility that's ADA compliant. So again, need to consider what's there and how the contractor is going to build it to give them the appropriate information. So in these conditions, standard construction detail is not going to tell you much, and you're going to need to give more specific grades and create a detail which shows how the department is intending for you to construct that location. So the image on the left side of the screen is the detail that you provide to the contractor in the plans, and you can see we decided to provide slopes as well as distances for all the pertinent elements. So that way the contractor is going to be given the curb line, the elevations at the curb line, and elevations at the depressed. They're going to give them the northings, eastings, and the elevations at the depressed curb limit, and they can build back in everything they need to off of those elevations and distances, or sorry, the grades and distances. And the idea is that this will be all used under their construction engineering funds to lay out that facility. And again, this is for the very, very constrained environment. So I mentioned this before, is design implementation. So the two big things driving the design implementation is that accessibility buffer that we discussed, as well as the updated details. So those two things made it so that we wanted to adopt a phased approach. So the department instituted a implementation date of April 1st, 2020, or 2022, sorry. And that's, again, based on the accessibility buffer and standard construction details. We also provided a flow chart in that implementation memo to try to assist the user in figuring out how should I approach this and approach this update. Basically, if you can incorporate the new standards, please do. We discussed them. We think that they're good practices to follow, and it's going to lead to less issues in the field. However, if there's project constraints local to your project that's not going to allow that, then we do understand that. And the way that we can move around that, even if you're after that implementation date, is you can add on a case-by-case basis the current details, which is the big thing from a contract document standpoint, back into your plans. And the way you can do that is you can grab it from the Design Resource Center publications page by clicking the MicroStation icon and downloading the MicroStation file. And according to the contract hierarchy, the construction details override the standard construction details, and you're good to go. Chapter 5. So Chapter 5 is a new chapter, as we mentioned before, and the idea is provide additional transparency to the inspection acceptance process. This is something that was highlighted during the development process that we want to make this more transparent to the staff. So inspection acceptance process, it overall follows the path you probably think of. Build the features, and inspect the features, and accept the features. And that's what this flow chart lays out. ADA inspection. So this is the procedures for the ADA inspection. The goal of the ADA inspection, call them out, and they're going to measure and subsequently document all required accessibility measurements for all new and reconstructed features. And they're going to document that in their ACIA application. So the goal of the department to have this ADA inspection occur either simultaneously or prior to the initial inspection. And the reason for that is that way the ADA issues that are discovered during the ADA inspection can be documented into that initial inspection punch list. And it also allows for the contractor to address those issues before they demobilize from the site. All ADA inspections must be performed prior to the primary inspection. The group that is administering the construction are the ones that are going to be tasked with requesting those inspections. On larger construction projects and on open-ended contracts, the construction group should give consideration to requesting as geographic locations of work are completed or as phases are completed, just to make it easier chunks to break off. And the engineering support section will perform the ADA inspections. They will document the deficiencies, and they'll alert the administering construction group once all the information has been added to the ACIA application and deficiencies are highlighted. The administering construction group can respond to each deficiency highlighted either with a picture or a statement if they disagree. And that once they're done responding, they can submit that to, they'll submit that to the DelDOT Title II coordinator. The DelDOT Title II coordinator then steps in as part of the acceptance process and will review that inspection report. If the inspection or the Title II coordinator says, yep, the construction did everything they need to, we have an accessible network, we're good to go, the Title II coordinator will issue a letter recommending acceptance into the maintenance inventory to the construction group, and the construction group will turn that over to the maintenance group at time of acceptance. If the Title II coordinator agrees or disagrees with the construction group and says that, no, you did not meet the accessibility requirements, they will issue a findings report which says these elements still need to be addressed. And at that point, the construction group, the engineer of record, and any other pertinent section should work with the Title II coordinator to find some sort of common ground or find a path forward on those issues that are currently not acceptable. Another thing that we did in this chapter is we tried to give more transparency to the actual inspection. So we added common facility types. So on the screen, there's a perpendicular curb ramp. In the perpendicular curb ramp, we show it and we transpose where we're going to be measuring locations for ADA compliance on top of it. All the features we're measuring compliance are standards in the manual. So the example here, I'll give you G and H. That's the running slope and the cross slope of the turning space. So that tells the user where to measure on top of the curb ramp. In addition to that figure, we have a table. The table says exactly how we're measuring that criteria. So G and H, I gave you before, it's a percentage and it's a slope. It's a slope of the turning space cross slope, and it's the running slope of the turning space. We also say where we're going to measure it. We're going to measure it in the middle of that turning space. And we also say what's required from an accessibility standpoint. We're not saying what's required from the contract requirements. So for example, we said we want to do 1.5% as our layout, but we're required to do 2%. So that's the 2% is what's on that chart. If you meet those 2%, you're good from an ADA standpoint. Again, the goal is to try to create transparency through the process for this for all the users involved. So now we come to Chapter 6, request for practical exceptions. So requests for practical exceptions are required where we're not able to meet the standards in Chapter 3 and where you have to meet the standards according to Chapter 2 of the manual. So you can, requests for practical exceptions can occur for physical constraints are encountered or for public safety considerations or operational issues. Again, this is some CFR language that come on this slide. Again, the CFR is a lot of the how and when to apply the standards. And a couple of key excerpts from this is full compliance with the requirements of this section is not required where a public entity can demonstrate it is structurally impracticable to meet the requirements. Again, also want to meet to the maximum extent feasible. Overall, the language is very clear in the CFR is that if you can meet or you're allowed to not meet the standards provided that it's structurally infeasible or impractical. And if you aren't able to meet the standards, you need to meet them to the maximum extent feasible. So RP documentation requirements. So RPs primarily are generated for two reasons. One, it gives the department a chance to review a location to make sure that sufficient work and sufficient analysis was done before we say, yeah, we couldn't meet the standard. The other thing it does is it creates an archivable document that summarizes the challenges and decision-making process and rationale used in cases where, and it becomes that document the department can fall back to if a complaint comes up years down the road. Accordingly, the RP must be written clearly, succinctly, and sufficiently document the following items. Need to fully discuss the project scope. That's one of the things that's probably most critical to the RPE. The project scope is going to drive everything. If it's a new construction, there shouldn't be much reason to violate the standards that's in the manual. If it's an alteration, which is the majority of our work, there could be items out there based on the scope of the project that just aren't going to be able to be addressed. We need to cite the specific warrants for the creation of the RPA. We'll talk about the warrants coming up. We need to document the features that will not meet the accessibility standards contained in this manual. We need to discuss the alternatives that we proposed, the alternative that we're proposing, why it's the best alternative and other considerations. We also need to analyze why it's not a decrease in the usability of the facility. And again, the key here is please write these to be clear and to be clear to anybody that's picking up this RPA. Someone that, you know, if the Title II coordinator moves on and we have a new Title II coordinator, they need to pick up this document and be able to defend the department. So the warrants for the RPA. So the ADAG and the PROWAG both contain some locations that consider where a RP may be applicable. So we took the requirements that's in the language in the ADAG and PROWAG, and we also investigated what other user agencies are using as their warrants. We did this to try to offer better guidance to staff and to also better categorize the RP information and when you're allowed to get an RP and when you're not. And so the result of that is the warrants on the screen. Again, real quick again, tying this back to the scope, highlight the right-of-way availability. So the wording that we use, which is commensurate with multiple other user agencies, is that the warrant here is a location where adopting the minimum standard contained in this manual will require purchasing additional right-of-way, and the project scope would not otherwise require the purchase of additional right-of-way. Again, it's based on the scope of the project. Some more RP warrants. And the one thing that I'm going to call your attention to is that on these warrants, based on the DOJ and DOT guidance, is that cost cannot be a reason for the entity not to perform the work. The limiting factor is the scope. So keep that in mind as you're generating these RPs. We wanted to provide more explicit content and more direct content to the staff that are generating these RPs. We broke up the RPs based on the project development phase in which they're occurring. So accordingly, we have design phase RPs, construction phase RPEs, and administrative RPEs. So the goal of the department is to get these done during the design phase. Let's highlight these areas where we have a chance to do something about them and properly analyze them, and let's document them during the design phase. The department got together and we said that semifinal plans is probably an applicable time frame to get these done, or other equivalent plan development milestone based on the individual project delivery method. If it's discovered during the construction phase, ideally we don't want to do this, but we can discover during the construction phase that an item that is required to meet standard won't meet standard. The construction group should reach out to the engineer of record and confirm the design intent. If the designer confirms that we're not going to meet the standard, at this point, the designer should be the one processing the RPA. The designer is the one more familiar with the project scope and the limitations of the project, and they should be the one putting together the RPE documentation. And finally, we have the administrative request for practical exception. So this is to be used just by the civil rights section. It should be used sparingly. And the idea is that if there's a location that doesn't readily fit into the construction phase or design phase RPA, that the civil rights group can document the non-compliance as they see fit. So RPE documentation requirements. Again, very important to document the RPA and the contents of the RPA. So on the right side of the slide, we have what's going to be documented in the plans. We show a non-complying ramp slope, and we have a note as on the plans that says that a request for practical exception has been obtained for this location, and that RPA should be provided to the construction inspection staff prior to construction so they can review it, make sure they concur with it, and understand it. And from there, the construction inspection staff can do with it as they please. Additionally, you need to fill out the RPE request form. So the RPE form itself that's shown on the screen, that's meant as a cover sheet and executive summary. If you feel the need to write a book, feel free to write a book. It's not required, but I'm sure Tom would appreciate it. And but you need to justify that, and this doesn't have to be limited to just that one sheet. So the RPE form, quickly walk through what's included in the RPE form. So in the first slide here, general information about the project, so contract name, contract number, the project purpose. So that's where we get into the scope. You need to clearly state what the scope of the project is. That way we're not chasing items that are outside of the scope. And it's also clear documentation for the user that picks up after us. Pedestrian facility type, so our project type, so that's the project type from Chapter 2 of the PASS manual for the facility that won't meet the requirements. Document the pedestrian facility type, so if it's a sidewalk, on-street parking, let the user know what doesn't meet the requirements. Location description, again, this is made to be something that someone can access 20 years from now, so provide a clear description of where the RP is occurring. And then document the non-complying element. And we gave you a spot as well to checkbox warrants. So if you say drainage is my warrant, I can checkbox the warrant. But then we also give you a spot to fully describe in a text box what that drainage, what that facility is that won't meet the warrant or what requires the warrant. So the next part of the form is the meat and potatoes of the form. So the meat and potatoes of the form is about the evaluation that took place. Why is what you're recommending the best alternative? Why is it not a decrease in usability? And what was your evaluation process? So this, again, is the meat and the potatoes of the form. What did the user do to justify an RPA? At the bottom here, we kind of encourage the user to provide certain items with the RPA. Again, needs to be just very easy for someone to pick up 20 years from now. So we're requesting a location map, a schematic of the existing location, so you can easily follow the logic. And so again, check off those items as you have them, trying to push the user to provide certain items. And anything that, again, that they want to provide, they're more than welcome to provide by doing so and listing in the enclosures box at the bottom. So finally, RP is good. Good to sign the RPA. Signature process, please follow the PM 18002 or PM 19001. That tells you how to sign the form. And then the prepared by location should either be signed by the engineer of record or should be signed by someone under the supervision of the engineer of record. The reviewed by should be someone that's competent in the field of accessibility, and ideally should be signed by somebody in the department, in the section that's generating the RPE. Shouldn't be signed by a consultant, should be signed by DelDOT. This is a DelDOT review before it goes to Title II coordinator. The approved by line will always be the DelDOT Title II coordinator. So we have Title II coordinator listed there at the bottom who will approve the RPE. So again, looked at the plan, or looked at different processes around the department and said, where can we make some improvements along the way? One of the things that we identified was creating a plan review process that specifically looked for disability or for accessibility issues during the design phase. Let's try to catch these during the design phase before they get into inspection and construction. And then we're having issues with the contractor on site and trying to figure out what to do. So the goal is to try to catch these early on in the project development process. To assist in that, we created a checklist that'll be used by the reviewer. And the checklist is aimed to keep the review focused. We want them to be focused on the accessibility requirements, not on preferential treatments. And we also want to make sure it's a thorough review. I want them to think about all the things where accessibility issues could come into play in the plans. Again, the goal is ounce of prevention worth a pound of cure. Let's review these on the front end, catch these, and then we're not arguing on the back end where it's much more costly. So the goal of this form, we'll go through it, check off what we need to check off from the reviewer standpoint. The form is meant for the reviewer. Once the reviewer is done, they'll take the deficiencies they found and then provide them back to the DelDOT project manager in the mechanism that they would prefer, which should be a Bluebeam Studio session. So we'll add the comments about accessibility to the Bluebeam Studio session. One thing to note as well is that anyone can still comment on the accessibility related items, but the task of being the opinion of the department has been given to the Title II coordinator. So the Title II coordinator is going to be looking at this strictly for the accessibility. Also created a similar checklist for RPE reviews. So again, keep the RPE review thorough and consistent and make sure that we're documenting what we need to document. So one thing that we realized pretty early on in the update is that we're not going to fix everything with this manual or the processes. It's just not going to happen. So what we decided to do was do a train the trainer. We had that on Monday, and the idea behind that is to create some subject matter experts and champions across the department. And so that way, if there is an issue, a localized issue, if there's a question, let's go to our champion and let's get a lot of these knocked out before we get too far into the process. That champion can always rely on other folks from around the department, and they can also rely on DelDOT's Title II coordinator to offer their opinion and their recommendation. However, we wanted to try to give that knowledge base out further to try to alleviate some of these issues because, we're not naive. There will be issues that come up in the field. So these are the DelDOT staff that were volunteered or voluntold to attend the train the trainer. So now they're experts and ready to teach up. And at the bottom is Tom Nickel. He is the DelDOT Title II coordinator. He's a great resource. And the email address for the Title II coordinator is the email address that's provided at the bottom here. So review learning objectives. I just want to prove to you that I did what I told you I was going to do. So we're good on that. And then thank you. Appreciate you guys' time. I know 4 hours is a big ask, and greatly appreciate the time. And hopefully this is beneficial to you. John, we got some trivia questions. And please add Q&A to the chat box as well. Rob is very lonely back there. So our first trivia question, which statement about a diagonal curb ramp is untrue? And we give you a couple options, and please fill in accordingly. Good answer. Hopefully you have more than one response. All right, so I think we're good. I don't see any other answers appearing. It looks like we're 100% on that one. So the group nailed it. So yes, diagonal curb ramp. The definition that we've adopted can measure it with other user agencies, as well as FHWA, AASHTO, and previous access board documents. Diagonal curb ramp serves 2 pedestrian street crossings. Which of the following is not a requirement under the ADA for pedestrian push buttons? Uh-oh. So we got a 2-horse race here. So everyone agrees on reach ranges. And the key to this question, if you're going to vote more than once, is that from an accessibility standpoint, what is the requirement? So it looks like you're pretty much in a dead heat. So the answer is that a level landing is not required. The level landing requirement is a should condition in the MUTCD. Going back to what we talked about before, though, is consider the turning space and any turning maneuver that might be required at that push button. So which statement is true according to the Department and federal definitions? This is a square and rectangle question. I'm very pleased so far. Very nice. So 100%, I think that's close enough or good enough. Yes, all curb ramps are pedestrian connections. Not all pedestrian connections are curb ramps. And I think we tried to make that abundantly clear in the updated manual. It's a little bit longer one. So this is going to be the time killer for the next 25 minutes. So which statement about request for practical exceptions is untrue? All right, well, I think we're good to answer, right? So I know it's a little bit longer of a one, but B is the correct answer. If you violate a guidance, you violated a guidance, not a standard. The guidances are best practices, and you're permitted to violate them. Should you? Out of routine, no, but you are permitted to violate those guidances. We have another one.
All right. All right, that's all the questions we had for today. We're going to leave the Q&A feature open for another 10 minutes or so, just in case anything else comes in. We had a few come in, and hopefully you guys are able to view those by clicking on the Q&A, see the responses to some of those questions. So I just want to thank Mike and Rob and the team at GPI for preparing the updated manual, as well as these other documents and the training for us. I think it was very beneficial for the department. Thank you all that have attended. Hopefully you got something out of this. And you will be sent the evaluation form, like I said earlier. And if you want to receive PDHs, you'll have to submit that by October 29th. The training was recorded and will be available on the DRC somewhere in the near future, as well as the slides, so you can refer back to that at a later time. And I think that's all I had. So thank you all for attending again, and have a great day.